Good evening, students. So in this particular class, we will move on to few more important topics related to slope deflection method, as well as we are just trying to do something related to your moment distribution method. So in yesterday class, we solved regarding slope deflection method. So what is the slope deflection equation? Slope deflection equation is given by say final moment MAB, which is equal to fixed end moment MFAB plus 2EI by L into 2 theta A plus theta B minus 3 delta by L. This is the slope deflection equation. Similarly, for further end or far end, we are having MBA, that is MAB. For further end, we are having MBA, which is equal to MFBA plus 2EI by L into 2 theta B plus theta A minus 3 delta by L. General one beam problem we solved. So in this particular class, let me discuss a few things regarding with respect to what is meant by sinking of support, as well as we try to discuss regarding frames. Okay, let me move on. Sinking of support. So the name itself indicates sinking of supports. Supports are sinking. Generally, beams are subjected to sinking and frames are subjected to sway. So when I'm saying that if support B sinks by delta mm and support C rises by say delta 1 mm, rises by delta 2 mm, then say for an example, it's a beam like this. I'm considering one example for beam like this, A, B, C, D. Now, this is the given beam, but here sinking conditions are given. Support B sinks by delta 1 mm. Support C rises by delta 2 mm. On these cases, see, this is the whatever the real beam, but A at same level, but B sinks. Sinks means it is moving in downward direction. Sinking means it is moving in downward direction of delta 1 mm, delta 1 mm. So at the same time, support C rises by delta 2 mm and support D at same condition. Now A at same level, B sinks, C rises, D at same level. Now what is the realistic behavior of the beam now? A will shift to B in downward fall because of sinking, and B here, your original support will shift it to point B. So now this is the simply supported support, and here once again it will rises. So have to connect this beam here at 2 mm delta to connect to this beam at this point. So this is the real beam. I'm representing in dotted line. So now A and B point. B sinks by 2 mm, sinks by delta 1 mm, So now the beam will come to here. Here the support, we are having simple support. So this is B. A at same level. But C will rises, not sinking, rises. I'm giving rises. See delta 2 mm. Now here I'm joining at delta 2 point and it come to whatever the position, real position. So now this is B point and this is C point and this is D point. My question is, say for an example, now when you are writing the slope deflection equation for this particular thing, for AB, which kind of rotation is responsible to create Sync like this. Sync like this. For AB and BA, which kind of rotation is responsible?
Clockwise.
Clockwise. So clockwise. Clockwise, what is the sign convention for clockwise?
Plus.
Plus. So clockwise is plus, anti-clockwise is minus. So this equation remains as it is. When you are writing this AB member, this equation will become, I am rewriting the equation, MAB equals MFAB plus 2EI by L into 2 theta A plus theta B minus 3 delta 1 by L. Why minus? Because anti-clockwise is positive. Plus into minus, it will become minus. If you are multiplying plus into minus, it will become minus only. Hence, so for MBA is also you are getting same equation. Here you are getting theta B, 2 theta B plus theta A. Any doubts in MAB member? Any doubts? Any doubts to write this slope deflection equation under sinking?
No, sir.
Okay, but if when you are writing a slope deflection equation for member BC, MBC, be careful when you are writing BC. What is the height of member? What is the total height of the member here to here? Full height.
Delta 1 plus delta 2.
Delta 1 plus delta 2 mm. So when you are writing for BC, you have to take MFBC plus 2EI by L into 2 theta B plus theta C minus, here which kind of rotation is responsible to create this kind of rotation for upward? Which kind of rotation is responsible?
Anti-clockwise.
Anti-clockwise. What is the sign convention? Anti-clockwise.
Negative.
Negative. Now this equation will become
Positive.
Plus.
Positive. Plus 3 times of delta 1 plus delta 2 divided by here L1, here L2. This is the equation. Very, very important thing. You may get in MCQs also. You may get in MCQ also. Clear? This is the concept you have to keep in your mind. Any doubts in sinking? I will give one more example. If I will give the question like, if support A sinks by 2 mm and B rises by 4 mm and C sinks by 8 mm. 8 mm. Pick up the proper real beam. So I will give some, I'm writing like this. Yes, what is the answer? Which one is the proper answer?
B, sir.
Others, what is the proper answer?
B.
B.
Second option, sir.
Second option. Why? If you consider a beam, say for an example, I am giving all are simply support a continuous beam. Support A sinks by 2 mm. Yes, okay, B. Support A sinks by 2 mm. Here I am assuming this is the support. Support A sinks by 2 mm. Next, support B rises by 4 mm. B rises by 4 mm. If you add these two things, the total height will become 6. And also once again, support C. Where is support C? Here. Support C sinks by
8 mm.
8 mm. Now, what is the total here to here is? Here to here is how much?
6.
This is also wrong. This is here to here is how much? 2.
6.
2, 8. 2 means here it will become 6 mm. Then only it is right. The option is none of this in that case. Have you got the things? Because I have given 2 mm, right?
Yes, sir.
If the shape, if I am asking the shape, then answer 2 is right. I'm not asking the shape. I have given the dimension, right?
Okay, sir.
When we are giving the dimension, you must be calculative. Clear? Any doubts? The overall depth is 6, but here to here height is 4 mm. Now I have given from C point 8 mm. Here total 8 mm. But I know that what is the height? This is 2 mm. So remaining height is
6, sir.
6 mm. You have to be careful while these questions, these kinds of questions, if they pick. Okay. Or in sometimes what they will do, they will give this condition and they will write the equations. So I will write now, I will write 4 equations. You have to pick one proper equation. Okay. For this is AB span. This is BC span. I will go for BC span. Which one is correct? With respect to this, which one is correct?
Sir, screen.
Yes. Which one is correct?
First option.
First option. Others? With respect to second diagram. Now I am reminding this. With respect to second diagram, which equation is correct? See, in last problem, I have asked the figure. In this diagram, I have given equation. Which equation is correct?
Sir, B, sir.
B. Others? So I got A and
Sir,
B.
it's option 3, sir. 3.
3. So I got 3 answers. 1, 2, 3. Others? None of this. Anybody? See, you have to think, right? I have given BC, right? So take the BC only. B. I have given BC. B and C. BC. What is the total height? Now? What is the total height?
12 mm.
This is 4 plus 8. 12 mm.
Yes.
12 mm is the total height, right? Now what is the equation? MBC equals MFBC plus 2EI by L2 multiplied by 2 theta B plus theta C minus C. For this kind of displacement, which kinds of rotations are responsible? Which kind of rotation? See, which kind of rotation?
Clockwise.
Clockwise. Clockwise means positive. So minus 3 into delta. 3 into delta I have given 12 by L2. So there is any option 12 into 3? What is
No,
the
sir.
option?
No, sir.
Then
None of the above.
what is the answer?
No, sir.
The answer is none of this. None of this. Simple, right? I have not given. I have not multiplied by 3. If I have multiplied by 3 in first option, that is first option. If it is anti-clockwise, then third option. Any doubts? ಅರ್ಥ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ಮತ್ತೆ ಹೇಳ್ತೀನಿ. Any doubts?
No, sir.
No doubts. Okay. Clear? Now, next we will move on to the frames. Sinking ಅಲ್ಲಿ ಇದು ನೋಡ್ಕೊಳ್ಳಿ ಸಾಕು. ಬೇರೆ in remaining steps are same. And also one more thing. Here I have not given mentioned L in L, so that's why L is mm. Okay. In some cases in problem, what they will do generally, they will mention L in meters and deflection in mm. On that condition, you have to divide that mm by 1000. You have to convert the given deflection into meters. Okay. Generally, it's a 20 marks question, so that kinds of related questions will not appear in MCQ. So MCQ, you may get like this type only. You have to think and you have to write the answers. You may get, the thing is diagram. Sometimes you may get equation with respect to sinking supports. Clear? Any doubts?
Sir, ಹಿಂದಿನ slide ಹೋಗ್ಬಿಡಿ sir ಒಂಚೂರು.
ಹಿಂದಿನ slide. Yes.
Sir, ಇದು delta 1 plus delta 2 ಒಂದ್ಸಲಿ ಪುನಃ ಹೇಳ್ಬಿಡಿ sir.
Okay pa. See, if support B sinks by delta 1 mm ಅಂತ ಕೊಟ್ಟಿದ್ದೀನಿ and support C rises by delta 2 mm ಅಂತ ಕೊಟ್ಟಿದ್ದೀನಿ. Okay, the given problem is like this. This is A, this is support B, and this is support C, and this is D. Now, this is that is imaginary horizontal section. A is not sinking, right as it is. This is A. D is also not sinking, right as it is. But B is sinking or rising. B is sinking or rising.
Sinking.
Sinking means below the baseline. Sinking by delta 1 mm. Now, your AB portion will come to here. This is AB shifted. Now C, at point C, it is rising or sinking?
Rising.
Rise.
Zinc.
So it is rising by delta 2 mm. You have to connect this and come to the join this. Now, what is the AB height? What is AB height? What is AB height? For AB, what is the delta value? What is delta AB? What is the height of AB?
Delta 1.
Delta 1 mm. What is delta BC? What is the height of delta BC?
Delta 1 plus delta 2.
That is delta 1 plus delta 2. Year to year height, full. Delta 1 plus delta 2. This height is delta 1 plus delta 2. Any doubts now? Clear?
Yes, sir.
Now, what is the height of CD?
Delta 2.
M delta AB, which is delta BA. Delta BC, which is delta CB. What is the delta CD? What is the height?
Delta 2.
Delta 2 mm, which is equal to delta DC. So this is very, very important. Any doubts?
Yes, sir.
ಇಷ್ಟೇ ಇದನ್ನ ತಿಳ್ಕೊಂಡಿದ್ರೆ ಸಾಕು ಸಿಂಕಿಂಗ್ ಅಂತ ಬಂದಾಗ ಅವನೇನ ಸಿಂಕಿಂಗ್ ರೈಸಿಂಗ್ ಅಂತೆಲ್ಲ ಕೊಟ್ಟು ನಿಮಗೆ ಈ ಡಿಫ್ಲೆಕ್ಟೆಡ್ ಬೀಮ್ ಶೇಪ್ ಬರ್ದ್ಬಿಡ್ತಾನೆ ನೀವು ಐಡೆಂಟಿಫೈ ಮಾಡಿ ಅಂತ ವಿತ್ ಡಿಸ್ಟೆನ್ಸ್ ಕೊಟ್ರೆ ಲಾಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ವಿತ್ ಡಿಸ್ಟೆನ್ಸ್ in some cases I will give one last example on sinking support. Next we will move on to the frame. So ನಿಮ್ಗೆ ಟ್ರೈ ಮಾಡಿ ಇದೊಂದು ಯಾವ ತರ ಬರೀತೀರಾ ಅಂತ. So I will give the beam also. So ABCD beam in which A sinks by 3 mm, B sinks by 5 mm, C rises by 12 mm. Yes, write the deflected shape. Try to write the deflected shape. And also I require the member deflections. What is delta AB? What is delta BC? What is delta CD? These three values. You may get in MCQ, delta AB, delta BC also. In MCQ, they will give delta BC equal 8 mm, 10 mm, 14 mm like that. Yes, what is AB? Fast, this is 2 minutes, 1 minute, 1 minute. What is AB? What
5
is
mm.
8 mm. How much? What is AB?
5 mm.
5 mm. What is BC?
17 mm.
17 mm. What is CD?
12 mm.
12 mm. Others, any other answers? This is first set of answers. Others, please try. Whether it is right or wrong, nothing to worry. You are came here to learn the subject. Please attempt. Yes. Second set of answers. ಇನ್ನು ಯಾರು ಮಾಡಿಲ್ವಾ ಸೆಕೆಂಡ್ ಸೆಟ್ ಆಫ್ ಆನ್ಸರ್ಸ್
ಸರ್ ಡೆಲ್ಟಾ ಎ ಬಿ ಮಾತ್ರ 3 mm ಸರ್ ಮಿಕ್ಕಿದ್ದು
3 mm BC
Same, sir. 17 and 12 next.
17 and 12. Others, any other answers? I think Shambhavi and Chidanand. Inyarappa ಹೇಳಿದ್ದು ಇಬ್ಬರನ್ನ ಹೇಳಿದ್ದು others? I'm right?
Rachana.
ಯಾರಮ್ಮ ಹೇಳಿದ್ದು ಶಾಂಭವಿನೇನ ಅದು?
Rachana, sir.
Rachana, okay. I'm confused with two people. So, okay, Rachana and Chidanand, ನೀವೇನ ಹೇಳಿದ್ದು ಇನ್ಯಾರು?
Darshan, sir.
Darshan, very good. Darshan, Rachana. Others, Chidanand? No, okay, no problem. But you have to attempt, okay? See, A sinks by 3 mm. See, first write the deflection, real beam. This is the real beam, right as it is. See, this support will sinks by 3 mm. This support will sinks by 3 mm. Now, your support is shifted to 3 mm here. Your support is shifted. This is A now. Now B. What is B? Here, support B. B is sinks by 5 mm. This B sinks by 5 mm. 5 mm. With respect to real beam. With respect to real beam, we have to take the dimension. Support C rises by 12 mm. Support C with respect to this height, 12 mm. Remaining here, D as it is. Now join this. Here, first point is this. Here, it is A, B. Now join this. Join this. So this is C. Now join this. Join this. Now, please observe the distance. What is the AB height? What is the AB height?
2
What is
mm.
the AB height?
2 mm.
5. This is 3. What is the AB height? 5 minus 3. 2 mm. What is the BC height? What is the BC height? What is the BC
17,
height?
17 mm.
Yes, 12 plus 5. 17 mm. Then, what is the CD height?
12 mm.
12 mm. See, where you have committed a mistake, please observe. I think both of you done a small mistake. Why 5 mm? How you thought it is 5 mm?
I thought with the respect to the original.
Original beam height. But AB length you have to take, right?
Okay, sir.
Okay, how you thought 3 mm? Darshan?
Sir, with respect to AB 3 irutte, BA 5 irutte ankonde.
You thought with respect to joint A, you thought with respect to joint B, right?
Yes,
So
sir.
don't do the mistake. It's okay, nothing. Now you just observe that is the length of AB beam. Where it is the length? That is 5 minus 3, 2 mm. Clear? Any doubts?
No, sir.
Okay. So please replace with this. Good. Nice attempt. So ಈ ತರ ಕೇಳ್ತಾನೆ ನಿಮಗೆ ಡೆಲ್ಟಾ ಎಬಿನೇ ಎತ್ತ ಹಾಕ್ಬಿಡ್ತಾನೆ. What is the deflection ಅಂತ? So any doubts? ಗೊತ್ತಾಯ್ತಾ ಇಲ್ವಾ? Yes, ರಚನಾ ಗೊತ್ತಾಯ್ತು ನಮ್ಮ ಚಿದಾನಂದ್ ಇದ್ದಾನ ಇಲ್ವಾ ಇವತ್ತು ಬಂದಿಲ್ಲ ಮೇ ಬಿ.
Yes, sir.
Okay. Good. Shall I move on to the frame problem?
Yes, sir.
Okay. See, in case of frames, normal portal frames, nothing to worry about that particular things. This is a regular procedure, but I will focus on sway frames. Generally, they will ask sway frames. Okay. With the concept, I will try to explain what is meant by sway and all, but generally they will ask sway frame. All rectilinear frames are sway frames. Andre rectangle type ಯಾವ frame ಗಳು ಬರ್ತದೋ ಅದನ್ನ sway frame ಅಂತ ಕರಿತೀವಿ. Okay. See, generally I will just assume, for the sake of purpose, I will assume some few loading. Okay, say 2 kilonewton per meter, say 4 kilonewton per meter, and 20 kilonewton. I will not going in detail for this problem. I will briefly explain which type of MCQ you may expect. Okay. So 6 meter, 4 meter, 2 meter, and 2 meter. Okay. Now, what is the first step? What is the first step? What is the first step in your SD method? Kinematic indeterminacy. Just tell me, what is the kinematic indeterminacy of the given frame? So you may get in MCQ. Identify the kinematic indeterminacy. I will give the option. In first step only, I have set it MCQ question. What is the kinematic indeterminacy of the given structure? I will give 4 options. I will give like 3, B is 2, C is 4, D is 1. Which one is correct? Which one is correct? Guess, no problem.
It's 4, sir.
4. Any other answers? Any other answers? I will explain the concept. Nothing to worry. To guess madri. Any guesses? How would you guess that is 4? Yes.
Times of J minus of M
Okay. You
plus
have
R.
applied the decay equation. Okay. When I am asking kinematic intensity, don't go for like that type of equations and all. Just write the whatever the given frame. Please observe here. It's very, very important thing. Generally, they will ask in MCQ questions. Okay. So what they'll do at each joint, you know that how many displacement at each joint? At each joint, 3 displacements, 2 rotations, 1 rotation and 2 translation. XY translation and rotation. Here also possible. These are not mandatory, possible. These are the possible at each joints. Each joints. Now, fixity. How many reaction will develop? How many external reactions will develop at fixed support?
0.
3. That's why 0. 3 reactions. Hence it is 0. Okay. Here hinge. How many reactions? At hinge, how many reactions?
2.
2. Therefore, rotation is possible. If you take A, B, C, and D, theta D is possible. Remaining 2 are 0. Okay. When you come to this, I have told that always the thing is this is possible theta B. Because of this fixity, this will become 0. Because of this hinge, here you are having reaction. This translation is 0. And this is possible. Theta C is possible. Now, all rectilinear frames are subjected to sway. All rectilinear frames are subjected to sway. How it will bend? So it will shift to this position as well as this shift to the same, whatever here the displacement delta, the same amount of delta is shifted. Therefore, the kinematic indeterminacy equals theta B, theta C, theta D and delta. Don't take delta B, delta C. Delta B, delta C combined together only one equal amount it will shift. So how many kinematic indeterminacy? 4. Very good. 4 is the right answer. Theta B, theta C, theta D, delta. They may give like ನೋಡಮ್ಮ ನೀನು ಈಕ್ವೇಶನ್ ಹಾಕ್ದಂಗ್ ಮಾಡಿದ್ದು ರಚನಾ ಸರಿ ಬಂದಿದೆ. ಬಟ್ ಆದ್ರೆ ನಿಮ್ಗೆ ಏನಂದ್ರೆ ಇದು ಗೊತ್ತಿರಬೇಕು ಯಾವ ಯಾವುದು ವಾಟ್ ಆರ್ ದೋಸ್ ಅಂತ. They can give in MCQ question what are the kinematic indeterminacies? Theta A, theta C, theta D. Second option theta A, theta B, delta. Third option theta B, theta C, theta D and delta. Fourth option none of these or any other combination. So on that case you have to identify these kinds and you have to go for proper answer. Any doubts? Any doubts? In first step I have stated 2 kinds of MCQ. In only first step of the problem you may get the question. Any doubts? Any doubts?
Sir, repeat, sir.
Repeat. Okay. I will explain from scratch, nothing to worry. You just concentrate on this because see, why I am taking time means I am covering MD method also. Moment distribution, these are all the basic steps. If you know SD method, MD method, you can understand within 10 to 15 minutes. Here, which kind of joint it is? Fixity. So the joint displacements are, because you are getting 3 reactions, right? At fixed support, these 3 reactions will not allow any kind of deformation. Hence 0, 0, 0. Here, hinge. Hinge means 2 reactions. This is 0, this is 0. But this is possible. Theta D is possible. Theta D is possible. If you come to this joint and this joint, here theta B is possible. Theta C is possible. But because of this fixity, this vertical is 0. Because of this hinge, this vertical is also 0. But delta, here delta is possible. Here delta is also possible. Thus, whatever the frame, delta moment, that is same amount. This is also delta. This is not also delta, which means delta B, which is equal to delta C, which is delta. same amount it will move. That's why we are not taking it as delta B, delta C. We are considering as a single quantity, single unknown, delta. Therefore, what are the total deformation, total kinematic indeterminates? Kinematics indeterminates are here theta B, here theta C, and here theta D and delta. So the total kinematic indeterminacies are 4. Any doubts?
No, sir.
Okay, this is very, very important. This is very, very important. The very first step to identify the kinematic indeterminacy. Beam ಅಲ್ಲಿ ಈಸಿಯಾಗಿ ಮಾಡ್ತೀರಾ, ಕಾಲಮ್ ಕೊಟ್ಟಾಗಲೂ ಅಷ್ಟೇ, ರೆಕ್ಟಾಂಗಲ್ ಕೊಟ್ಟ ಅಂದ್ರೆ ಮುಗೀತು. ಅದೇ ನಿಮ್ಗೆ ಇನ್ನೊಂದು ಸಿಂಪಲ್ ಕೊಡ್ತೀನಿ ಫ್ರೇಮ್. ಇದಕ್ಕೆ ಎಷ್ಟು ಹೇಳಿ ನನಗೆ? I have given fixed. Now what is the total indeterminacy? I have given fixed support, rectilinear.
2, 3.
2.
3, sir. 3. 3, sir. 3.
Yes, sir. 3, 3.
What are those?
Delta, theta B, theta C, and delta.
Theta B, theta C, delta. ನಿಮ್ಗೆ ಅದು ಗೊತ್ತಿರಬೇಕು. ಯಾಕೆ ಅಂದ್ರೆ ನಿಮ್ಗೆ MCQ ನಲ್ಲಿ ನಂಬರ್ಸ್ ಆರು ಕೇಳಬಹುದು, ಇಲ್ಲ ಅನ್ನೋನ್ಸ್ ಮೆನ್ಷನ್ ಮಾಡಬಹುದು. Any doubts? Any doubts? Next, I will give a small. This is not rectilinear frame. It is a portal frame. It is a portal frame. Here delta will not come. Rectangle idre matra delta barutte. Idakkella delta baralla. Yes, here. What is the kinematic indeterminacy? Guess.
1.
1, sir. 1.
What?
Theta C.
One. Only one.
Theta
See,
C.
here 0. Here also 0. But here theta B is possible. But this fixity it will not allow. This fixity will not allow. Here hinge. These are 0. But this is possible. Theta C is possible. Hinge. Rotation is possible. So total kinematic indeterminacy is how much?
2. Theta C.
Theta B and theta C. See, ಈ ತರ ಸಿಂಪಲ್ ಕ್ವಶನ್ ಆಗ್ದಾಗ ಏನೇನೋ ಮಾಡಬಾರ್ದು, ಯೋಚನೆ ಮಾಡ್ಬೇಕು. ಅಲ್ಲೇ ಇದು ನಿಮ್ಗೆ ಏನ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಷ್ಟೇ. ಕೈನಮ್ಯಾಟಿಕ್ ಇಂಡೆಟರ್ಮಿನೆಸಿ, ಸ್ಟ್ಯಾಟಿಕ್ ಇಂಡೆಟರ್ಮಿನೆಸಿ ಒಂದು ಕ್ವಶನ್ ಪಕ್ಕ, 1 or 2 questions. If the setter is smart, they will pick in basic level. Okay, next I will give one more frame. Yes, I'll give you. Generally, once I have set it for your some competitive exam, I have given this frame. What is the kinematic indeterminacy? What is the kinematic indeterminacy?
2.
2.
3.
3. Any other answers? Either 2 or 3, because here it is fixed. That is clear. Here 0 clear. Either you are having only 2 options, theta B, theta C, or theta B, theta C, delta. Which one is correct?
2.
2.
3, sir.
3. See,
Yes, sir.
this is also rectilinear frame. So theta B is possible, theta C is possible. This frame also will
Delta.
having delta like this. They may give like this. They may give the deflected pattern also. Which one is the real beam? Real frame anta hakbiಟ್ಟು ಇದನ್ನು optional ಕೇಳಬಹುದು. This is the kinematic indeterminacy and deflected shape of the frame. ಅರ್ಥ ಆಯ್ತಾ? K equals theta B, theta C and delta. ಬರೀ ಇದನ್ನೇ ಕೇಳಬಹುದು. ಆರ್ ಫಿಗರ್ ನು ಕೇಳಬಹುದು. ನಿಮಗೆ ನಾರ್ಮಲ್ ಫಿಗರ್ ಕೊಟ್ಬಿಟ್ಟು, ಈ ನಾರ್ಮಲ್ ಫಿಗರ್ ಇದೆರಡನ್ನು ತೆಗೆದ್ಬಿಟ್ಟು, ಈ ನಾರ್ಮಲ್ ಫಿಗರ್ ಕೊಟ್ಬಿಟ್ಟು, guess which one is proper one ಅಂತ ನಿಮ್ಗೆ ಹಿಂಗ ಆಗ್ತಾನೆ. ಇದ ಆರ್, ಇದ ಆರ್, Ida. Which one is correct? Which one is correct? This is correct, or this is correct, or this one is correct. I have given 3 options. Which one is correct?
1 and 3.
Second.
1.
Second, sir.
Second.
1 and 3.
3. I have told all the 3. See, you have to guess smartly. Which one is correct? Yes, Rachna, Chidanand.
Sir, 1.
1. Darshan, Manjunath. 1. If you see, you just observe the pattern.
2, sir.
Okay.
3, sir.
See, if you are writing like this, then it must be like this only. Which one is correct now?
3, sir.
3,
sir.
1 and 3 both, sir.
1
Yes,
is
sir.
not possible, I think.
Yes,
See,
sir.
why it is not possible? If I have taken like this,
2 and 3 diagram will confuse it. Dotted line
ಕನ್ಫ್ಯೂಷನ್ ಆಗಬಾರ್ದು ಗೊತ್ತಾಯ್ತಾ. ಸೊ ಯಾಕೆಂದ್ರೆ ಇದು ಆಗಲ್ಲ, ಯಾಕೆ ಹೇಳಿ, ಇದು ಇಲ್ಲೇ ಬಂದ್ಬಿಟ್ಟಿದೆ ಈ ಫ್ರೇಮ್ ಡಿಫ್ಲೆಕ್ಷನ್. 1 ಆಗಲ್ಲ, ಚಾನ್ಸ್ ಇಲ್ಲ. 2 ನಲ್ಲಿ ಇದು ಇಲ್ಲಿ ಬಂದಿದೆ. ಸೊ ಇದು ಒಳಗಡೆ ಬರ್ಬೇಕಿತ್ತು, ಒಳಗಡೆ ಬಂದಿದ್ರೆ ಸರಿ. ಎಸ್, ಸೊ ದ 3 ಆನ್ಸರ್ 3 ಇಸ್ ರೈಟ್. ಸಿ, ಯಾವ ತರನಾರು ಡಿಫ್ಲೆಕ್ಷನ್ ಕೊಡ್ಬೋದು ಅನ್ನೋ ಅಸಂಪ್ಷನ್ ಅದು. ಅದು ಹಿಂಗೆ ಆಗ್ಬೇಕು ಹಂಗೆ ಆಗ್ಬೇಕು ಅಂತ ಏನ್ ರೂಲ್ ಇಲ್ಲ, ಆಯ್ತಾ. ಯು ಆರ್ ಅಸ್ಯೂಮಿಂಗ್ ದಿ ಡಿಫ್ಲೆಕ್ಷನ್ ಡೈರೆಕ್ಷನ್. Someone will going to assume positive direction, someone will going to assume negative direction. ಗೊತ್ತಾಯ್ತಾ?
Sir,
Clear?
can you explain it again by doing sway line with dotted?
Sway line. Okay. The same problem or some other problem?
Anything, sir.
Anything. Okay. If it is a rectangular frame, you are assuming like this sway. First condition. This is, you are assuming like this. This is positive sway. Then it must be how it will deflect. See, definitely it will come to here because this is delta. This is delta. The thing is simple. This length is same. This length is same. Or if you are assuming, inward, definitely it is outward. Clear?
Yes, sir.
It must be swing outward. If it is inside the frame, this one will go away. It will outside the frame, it will come within the frame. Or for the confusion purpose, we will sit there. For confusing students, we will sit like this. Like this. Now, if you do like this, see, I will represent in dotted lines. So you are going away. So you must come within the frame.
Okay.
This is right.
Okay,
Or
sir.
if you are coming inward, so you must go away. This is right.
Okay, sir.
This is the only the deflected shape. These are both are right. This is also right. This is also right. Sometimes they will give both the answer, but also in code they will give A and B both are right. A is only right, B is only right, and they will give one more pattern, and A and C are right, like that. Whatever they may be, they are having lot of option to set a MCQs. Any doubts?
No, sir.
Okay. So this is regarding the first step, kinematic indeterminacy. Second step, you know that FEM. So I'm not going to deal with that. Okay. I will ask one question on FEM also. I will set a few questions on frame. I will give this frame 20 kilonewton, 2 kilonewton per meter, 10 kilonewton, 2 meter, 2 meter, 4 meter. Okay. Now, what is, I will take this as A, B, C. Compute MF BA and MF BC. I will give 4 options. And that time you just try to compute. What is MFBA and what is MFBC? I'll give the first option. I'll give second option. Which one is right? Which one is correct?
C, sir.
B. Any other
C.
answers?
C, sir.
D. Okay,
C,
D.
C,
Any other answers?
C, sir.
Which one?
C.
C.
-5, 2.61, sir.
Any other answers?
C, sir.
C. Okay. See, when we are doing FEM, see, please remember, please take a note. FEM is always due to loads on members only. Members only. This is very, very important point. Fixed end moment is always due to member load only. Here, this is 20 is joint load. This 20 is joint load. So don't consider this joint load while you are computing your FEM. So FEM for you are going to consider only a member load. Even though you are not having the equation for joint load. Please remember, you are not having the equation for joint load. So if it is clockwise, if it is clockwise, see, this is clockwise rotating, it will rotate anti-clockwise. If it is clockwise, it will rotate anti-clockwise. So if it is anti-clockwise, it is anti-clockwise, it will rotate clockwise. It will rotate clockwise. So here also I have not given the option. +5 you are getting right. If it is clockwise, resisting moment, it is rotating anti-clockwise. Which is the resisting moment? Resisting moment in?
MFBA.
Yes, MFBA equals you are getting plus WL by
8.
8. So it is you are getting 5. But I have not given +5. So on that case, just leave the problem. You can appeal for grace marks. If you are attempting anything, you are losing the marks. Please be careful. Here I have not given intentionally the thing. By confusion, I have mentioned -5. But in my mind, it is running that C is option. But even though if I am the setter, I will give to KPSC as a C as an answer. But afterwards, we have to do, but it is coming 5. We will send a query when he release the key answers. On that time, you are getting grace marks. If you are not attempted, then only you are getting grace marks. If you attempt it, you are losing the marks. Clear? So instead of -5, if I am giving 5, and also see here also we made a mistake where for BC member, this is UDL. How it is rotating? Clockwise. What is the resisting? Anti-clockwise. So MFBC is minus WL square by 12. So minus 2 into 4 square by 12. Minus 32 by 12. How much? Minus 2.61. Minus 2.61. See, here I have not given minus 2.61. I have given plus 2.61. I have given the answer for MFAB and MFCB. Fixed end moment is always a resisting moment. I have explained yesterday class. Clear? So in this case, the answer should be plus 5 and minus 2.61. Plus 5 and minus 2.61. Any doubts? Any doubts? See, clear ಆಯ್ತಾ ಇಲ್ವಾ ಇದು FEM ಬರೆಯುವಾಗ ನಿಮಗೆ ಹೇಳಿದೆ ತಾನೆ ಇದು clockwise rotate ಆದ್ರೆ this end will anti-clockwise. If it is anti-clockwise, this end will clockwise. On that condition only, we will consider minus and plus. Yesterday class we discussed. Clear? Any doubts? Okay, nothing to worry. I will set one more question on FEM. Please try to solve this question. Will be very helpful. Okay, so please take a note. This FEM is always to only due to member loads. Okay. If the beam, if they won't set beam for FEM, they know. If they set beam, you are getting directly the answer. Yes, now tell me, what is the value of MFCB and MFBA and MFDC? Three values. What is the value of MFCB, MFBA, MFDC? I will give three options. Yes, option barak munchane ನೀವು ಆನ್ಸರ್ ಹೇಳಬೇಕು.
Sir, MFCB is 13.33.
You just tell like in first MFCB.
Yes, sir. It is WBA square.
No, I need answer. Final answer.
13.33.
13.33, comma.
15.
15, comma.
10.
10. Any other answers? I require 3 answers. Then we will decide which one is right. Myself also, I will write 3 answers. Yes, fast. So I will give one more answer.
Sir. Hello.
No, yes, Hedappa.
Minus 11.25.
Minus 11.25.
Minus 15.
Minus 15.
And plus 5.
5. Any other answers? Third option. Any other answers?
13.33, sir.
13.33.
15.
Next one?
15.
15.
10, sir.
10. You're getting same answer. Okay. Good. Others? I will give one more option. I will slightly modify your results. Let's see. Minus 13.33 I will give. And I will give once again minus 15 I will give. And I will give 5. Okay. None of this. Fourth option I will go for. None of this. Okay. Let's see. We will check one by one. See, first I will go to MFCB. CB. This one. CB. I require C and B. See, this is the force. 30. How it is rotating towards C? How it is rotating towards C?
Clockwise.
Clockwise. What is the resisting moment?
Anti-clockwise.
Anti-clockwise.
Anti-clockwise. So what is the sign?
Minus.
That's all. It's a simple thing, right? So you just see, if you are getting general sign convention, you can pick the answers. Now here I have given eccentric load. This is 2 meter. This is 1 meter. So this is BC, CB span. So MFCB, which is equals minus WBA square, not AB square. BA square by L square. You are getting 13.33. Please check. That is minus 13.33. Any doubts? Why it is minus? Have you got the answer? Why it is minus?
Yes.
Now BA. See BA. This is BA. Here fixed D. Here it fixed D. Here I am applying the load 30 kilonewton. I am asking BA, not AB. Towards BA. How it is rotating? How it is rotating? BA towards B. How it is rotating?
Clockwise.
What is the resisting?
Anti.
That's all. Negative. Any doubts? WL by 8. MFBA equals minus WL by 8. So you're getting minus 15. Please check. Please check. Next. BASO. DC. Here D. Here D. C. What am I asking? I'm asking DC. So towards D it will rotate. How it is rotating? How it is rotating towards D?
Anti-clockwise.
What is the resistance? Clockwise. It's positive. So MFDC equals minus WL by 8. Minus W is 20. L is 2 by 8. 2 4s are. Therefore, minus 5. Clockwise. Positive plus 5. See? What is the option? Which one is the option? See?
Sir, I have a doubt.
Yes.
If it is to BA, then it is coming from B towards A, right?
BA?
So if it is MFBA,
Huh?
so you have to consider
Huh?
the support is, the rotation is towards A, right?
No. AB means it is rotating towards A. BA means it is rotating towards B. BC means it is rotating towards here B. CB means it is rotating C. When this is a member, I am going AB, it is rotating towards A only. If it is a member, I am considering BA, it is rotating towards B. If it is a member, I am considering BZ, it will rotating towards B. It's a member, I am considering CB, it is rotating towards C. What is the confusion? Why it is confusion? Because always you are not getting downward loads. Always you are not getting like, see what happened when you are practicing the problem, you have practiced it like this, right? If it is a point load subjected to W, L by 2, L by 2, how it is rotating now? How? Towards AB, towards A, how it is rotating? Clockwise. What is the resistance? Anti-clockwise. So MFAB, how it is rotating? Anti-clockwise. What is the resistance? Clockwise. MFBA. So when you are writing equation, MFAB equals minus WL by 8. MFBA equals WL by 8. Why it is minus? It is anti-clockwise. Why it is plus? This is clockwise. Similarly, I have given like this. I have given like this. Where I have given the load? I have given the load here. I am giving the load here. Here A, here B. So now towards A, how it is rotating? Anti-clockwise. So what is the resistance? Clockwise. Towards B, how it is rotating? Clockwise. What is the resistance? Anti-clockwise. So this is MFBA and this is MFAB. So here MFBA is negative. Why it is rotating in anti-clockwise direction? Yes, any doubts?
No, sir.
Yes, you have to take an individual member and direction of the load, whether it is acting on or below, on right side, on left side. With respect to joint, you have to take a rotation.
Okay, sir.
If it is AB, you have to take A joint. It is BA, you have to take B joint. If it is BC, you have to take B joint. If it is CB, you have to take C joint.
Okay, sir.
Clear? Don't make any mistake. Clear? The concept is clear. This is the second step. The concept is clear. Okay. Next, I will move to the slope deflection equation. I think there is no doubt, but you can expect a few questions on that step also, but mainly on joint equilibrium condition, on swave condition. Okay. See, when you are writing for the same problem, slope deflection equation, how many slope deflection equations you are getting in this frame? That is the question. How many slope deflection equations are getting? Next, third step. In third step, you are getting slope deflection equation. See, don't miss the classes because these concepts are very, very important. This one, next moment distribution method, and also influence line. Very, very important. Slope deflection equation. My first question is, for this kind of frame, how many slope deflection equation? How many slope deflection equation? You know, kinematic intensity of this frame is 3. Now tell me, what is the how many slope deflection equation in this kind of frame, and also how many slope deflection equation in this frame, and also I will give one more frame. How many slope deflection equation in this frame? I'm asking a number. 1, 2, 3, 4. I'll give. You pick. For first one, how many slope deflection equation? For second one, how many slope deflection equation? For third one, how many slope deflection equation? Or I will revise the answers. I will give like 4, 8, 6, and I will give 7. Which one? Which? For first one, for first frame, what is the answer? For first frame, how many slope deflection equation?
Sir, 4.
4. Any other answers? For second frame?
Sir,
For,
sir.
for second frame, how many slope deflection equations?
Okay.
For second frame, how many slope deflection equations?
Sir, the second frame 4, sir.
Second frame 4. Okay. For first frame, for second frame 4. Okay. For first frame
2, sir.
2. Any other answers? For third frame
5.
5. Okay. Any other answers? Any other answers? Rachana, Shambhavi, Chidanand, I think Darshan. Yes, any other answers? Okay, I will explain. Please be concentrate. I'm asking very simple question. What I have asked? I have asked numbers. How many SD equation? See, for one member, what is the possible SD equation for AB member? Say AB member. What is the possible SD equation?
2.
2.
MAB and MBA. Here, how many members? Here, how many members?
2 members.
2 members. How many equations?
4.
4. Here, how many members?
Sir, it will be 6, sir.
Fix whatever it may be. There is no, that is how you are writing, where you are finding moments. Here you are finding moments, MAB, MBA, and MBC, and MCB. Here what you are finding, MAB, MBA, MBC, MCB, MCD, MDC. How many equations? 6. Here, MAB, MBA, MBC, MCD, MDC. How many equations?
6.
6, irrespective of joints. See, ultimately what you are going to compute? You are going to compute using slope deflection equation 2 moments in a one member. Why you are seeing the joints and all? Right? Any doubts? Clear? The concept is clear? They may ask, identify the number of slope deflection equations. In each member, you know that you have written MAB, MBA only. There are 2 equations for one member. Clear? Any doubts? Any doubts? Clear ಆಯ್ತಾ ಇಲ್ವಾ ಮತ್ತೆ ಹೇಳಬೇಕಾ?
Yes, yes, clear.
Okay. See, once we know about slope deflection equation, what is the next step? What is the next step? What is the next step?
Joint equilibrium equation.
Yes.
Conditions.
Joint equilibrium
Conditions.
condition. See, in SD method, ನಿಮಗೆ ಬೇರೆ ತರ ಏನು ಬರಲ್ಲ. ನಿಮಗೆ ಎಂಟೈರ್ ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಕ್ ಬಂದ್ರೆ ಮಾತ್ರ ನೀವು MCQ ಟಚ್ ಮಾಡಕ್ ಆಗೋದು. Joint equilibrium condition. See, we are talking about frame. This is very, very important. Now tell me, how many joint equilibrium condition in this frame? This is a question. This is also a very, very important question. How many joint equilibrium condition in this frame? And I will take one more frame. How many joint equilibrium conditions in this frame? And also how many joint equilibrium conditions in this frame? And also I will give one more. How many joint equilibrium conditions in this frame? Yes, first one by one move. This is the first problem. This is the second. This is the third. This is fourth. Okay. First, how many joint equilibrium condition here?
5.
5. Joint equilibrium. Joint equilibrium.
2, sir. 2.
2, sir.
4.
2.
How many joints are there? 1,
3.
2,
3
3.
joints.
Out of 3, this is fixed. At fixity, there is no joint equilibrium condition. Why? It will not allow. It is already in equilibrium. It is already in equilibrium. Fixed joint is already in equilibrium. Now B. What is the joint equilibrium condition at B? MBA plus MBC equals 0. What is the joint equilibrium at C? MCB equals 0. Therefore, how many number of joint equilibrium conditions?
2.
2. Very good. Here. Here.
It will be 3.
3. What are those?
One is MCB is equal to 0, and then M.
Yes. For second, how many equations?
3, sir.
I think someone got, yes, 3. What are those? At
MCB
A,
is equal to
0.
0.
At C, CB. MCB equals 0. At D, MDB equals 0. At B,
BC, BA, BD.
yes, MBC plus MBD plus MBA equals to 0. Right. Here, 3. Here, 2. For this,
1.
what is the what is the 1? That is this one plus this one plus this one. Very good. Only 1. Now tell me here. This is a sway frame. How many joint equilibrium condition?
2, sir.
2. 2. Any other answers? Yes, it is 2 only. Joint equilibrium conditions with respect to joint. Theta B, theta C. You are having in this particular thing. What is the kinematic indeterminacy?
3.
What is the kinematic indeterminacy?
3, sir.
3. What are those?
Theta
Theta B, theta C, deflection.
Theta B, theta C, and delta. Okay. Here, what is the kinematic indeterminacy? Here, what is the kinematic indeterminacy?
Theta B.
Theta B?
Delta.
Only theta B? Only theta B?
Theta C.
Theta C. Here, how many kinematic indeterminacy?
Theta B, theta D, theta C.
Theta B, theta D, theta C. Here, how many kinematic indeterminacy? Say it is B.
1. Theta B.
Theta B.
Theta B. Now tell me, what is the relationship? What is the relationship for portal frame between kinematic indeterminacy and joint equilibrium condition?
Same, equal.
Yes, what is the relationship?
Equal, sir. Kinematic indeterminacy is equal to
Kinematic indeterminacy is equal to joint equilibrium condition.
same numbers.
Yes, idunu niಮಗೆ ಕೇಳಬಹುದು. In non-sway frame, what did theta B, theta C all represent? It is the displacement. That is the joint equilibrium condition. You are how many equations you are having? That number of joint equilibrium equation you are getting. ಈ ರಿಲೇಶನ್ಶಿಪ್ ನಿಮ್ಗೆ MCQ ಹಾಕ್ಬಹುದು. ಎಷ್ಟು ಏನು ಅಂತ ಕೇಳ್ಬೋದು. ಗೊತ್ತಾಯ್ತಾ? ಎನಿ ಡೌಟ್ಸ್? Now tell me, here ಏನಾಯ್ತು? ಇಲ್ಲಿ ಏನಾಯ್ತು? ಇಲ್ಲಿ 2 ಇದೆ, ಇಲ್ಲಿ 3 ಇದೆ. ಯಾವ್ದು ಇನ್ನೊಂದು? ಇಲ್ಲಿ 2 ಜಾಯಿಂಟ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್, ಸರಿನಾ? ಜಾಯಿಂಟ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ಎಷ್ಟು?
2, sir.
2. What are those?
Theta B.
Theta B, theta C.
Yes, sir.
Yes, that's why joint, whatever the rotation, that is your slope. That is very, very important. But see, this is called rotation contribution. See, you just take a note. Always rotation contribution is equal to joint equilibrium condition. But in case of sway frames, in addition to rotation contribution, what you are having? What you are having? In addition to rotation contribution, what you are having?
Sway condition.
Sway contribution, that is delta. That is only in column sway. This one, this is delta. That's why kinematic independency is 3. So they may impose question like in sway frames, the condition is A, rotation, B, rotation plus sway, C, sway, D. Double sway. Which one is right?
Rotation plus sway.
Rotation plus sway. Always in sway frames, there is a rotation and there is a sway. Okay. So what is the conclusion? What is the inference we can make by using this statement? Here we have to apply two conditions, where in sway mechanism you are having two conditions. What are those conditions? One is rotation contribution using joint equilibrium condition, and another one is sway contribution. Sway contribution, that is also called shear contribution. That is also called shear contribution. Okay, ಅದನ್ನ ಹೇಗೆ ಮಾಡೋದು ಅಂತ ಅದ್ರ ಮೇಲೆ MCQ ಸಕ್ಕತ್ತಾಗಿ ಕೇಳಬಹುದು. ತುಂಬಾ ಚೆನ್ನಾಗಿ ಫ್ರೇಮ್ ಮಾಡಿರ್ತಾರೆ ಅದ್ರ ಮೇಲೆ. ಯಾವುದು ಸ್ವೇ, ಈ ಜಾಯಿಂಟ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ನೀವು ಹೇಳ್ತಾ ಇದ್ದೀರಾ, ಅದೇ ತರ ನಾನು ಇನ್ನೊಂದು ಏನ್ ಹೇಳ್ಬೇಕು ನೆಕ್ಸ್ಟ್ ನಿಮ್ಗೆ ಸ್ವೇ ಬಂದಾಗ ಸ್ವೇ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಮಾಡಬೇಕು. ಗೊತ್ತಾಯ್ತನ್ರೋ? ಸ್ವೇ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಮಾಡಬೇಕು. ಓಕೆ, ಇವಾಗ ನಿಮ್ಗೆ ನೋಡಿ ನೆಕ್ಸ್ಟ್ ಈಗ ತಗೊಳ್ತೀನಿ ಪ್ರಾಬ್ಲಮ್ ನ. See, this is the given problem. I will give a joint load of 20 kilonewton. And also there is a member load of 10 kilonewton. 2 meter, 2 meter. There is no load. Okay, 3 meter. EI is constant. Nothing to worry about EI. A, B, C, D. Now, what is the joint equilibrium condition for this member?
6.
See, first, okay, one by one we will go. How much? First, what is the kinematic independency? What is the kinematic independency for this structure?
Theta B.
3.
Theta B.
Theta C.
Theta C.
Theta C.
And delta.
And
Delta.
delta. So 3. Sarina? ಯಾವ್ಯಾವುದು ಅಂತ ನೀವು ಬರೆಯೋದಾದ್ರೆ you can represent like this. A, B, C, D. Here you are having 0, 0, 0. Here you are having 0, 0, 0. Here you are having theta C 0, 0. Here you are having theta B 0, 0. In addition to rotation, you are having sway. In addition to rotation, you are having delta sway. Okay, that is these three. Any doubts in this? Okay. Next, second. What is the joint equilibrium condition? How much? Yesterday, joint equilibrium.
2, sir.
2. 2 joint equilibrium conditions. 2. ಯಾವುದು joint?
B and C.
Joint B ನಲ್ಲಿ ಯಾವುದು?
BA, BC.
Moment BA plus BC.
BC equals 0. And joint C ಲಿ?
CV plus CD.
Very good. A plus CD equals 0. Okay. In addition to this, I can ask how many slope deflection equation you are getting? How many SD equations? How many SD equations? How many SD equations for this frame?
6.
6,
6, sir.
What are those?
Moment AB, moment BA,
BA,
moment
BC,
BC, moment CD.
CD, DC.
Moment CD and moment DC. ಸೊ ನಿಮ್ಗೆ ಇದು ಫಸ್ಟ್ ಸ್ಟೆಪ್, ಇದು ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ನಿಮಗೆ ಬಂದಿರುತ್ತೆ. ಅದನ್ನ ಥರ್ಡ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ತಗೊಂಡ್ಬಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀರಾ, ಇದಾಯ್ತು. ಇಲ್ಲಿವರೆಗೂ ರೆಗ್ಯುಲರ್ ಆಗೋಯ್ತು. ಯು ಆರ್ ಹ್ಯಾವಿಂಗ್ ಹಿಯರ್ 3, ಬಟ್ ಯು ಹ್ಯಾವ್ ಅಪ್ಲೈಡ್ 2. One is remaining. Which one is remaining?
Sway.
Which is remaining?
Deflections.
Sway. So that is your next step. Sway condition. See, here you are getting one equation. Here you are getting here one equation, but you require 3 unknowns: theta b, theta c, delta. Right? But how to arrive delta equation? That is very, very important. How to arrive delta equation? How to arrive delta equation? That is very, very important. That is called sway condition. See, please be careful. Please observe here. I will explain how to arrive one more equation. See, these two are very easy. But how to arrive the sway condition? That is one more very, very important thing. I am considering the only frame and joint load. See, in this problem, I have mentioned a joint load. In FEM, you are not considering this joint load. Where you have to consider this joint load? In sway condition, you must consider the joint loads. See, idunu kelbodu. In frames, in rectilinear frames or in sway frames, where we are going to consider the joint loads? At joint equilibrium condition, at sway conditions, or in slope deflection equation, or none of the above. So on that case, you have to say that the joint loads are, we are going to consider a sway condition or sway contribution. Okay. So here, just take this joint condition. How much? 20 kilonewton. And also you must consider all horizontal loads. All column ಮೇಲೆ ಯಾವ ಲೋಡ್ ಆಗ್ತಿದೆಯೋ ಅದನ್ನ ತಗೋಬೇಕು, ಅದನ್ನ ಮರ್ತು ಬಿಡಬೇಡಿ. ಯಾಕೆಂದ್ರೆ that is also will cause sway. ಅದನ್ನು ಸಹ ತಳ್ಳತ್ತೆ ಫ್ರೇಮ್ ನ. ಬಟ್ ಬೀಮ್ ಮೇಲೆ ಬರೋದು ಇಟ್ಸ್ ನಾಟ್ ರಿಕ್ವೈರ್ಡ್. ಆನ್ ಬೀಮ್ ಇಟ್ಸ್ ನಾಟ್ ರಿಕ್ವೈರ್ಡ್. Please consider load acting on the column joint, column beam joint, which means column joint, as well as load act on the column vertical members for sway condition. See, generally we are getting a moment MAB and also MBA. Ignore beam, only consider column. Here you are getting MCD. Initially, whatever the direction is, no matter, assume all clockwise. So these are the final moments. These are the, right? These are the, whatever these moments, MAB, MBA, MDC, these are the moments, right? Now what you have to do? You have to take sigma H equals 0. Sigma, you have to apply sway condition. Horizontal force equals 0. All right side forces positive, left side forces negative. All right side forces positive, left side forces negative. And also here, fixity. Fixity, how many reactions? In fixity, how many reactions?
3 reactions.
3. But we are considering only horizontal. Therefore, only consider horizontal. Here, this is A means HA, external reaction. Right? Here, this is D means here, what is the reaction? HD. Why I have taken only horizontal? Because we are considering only horizontal component in sway condition. Okay. Now, what is sigma H equals 0 for this whole column members or whole assembly? What is sigma H equals 0? Use this kind of sign convention.
HA plus HD plus 20.
HA plus HD 10 plus 10 plus
20
plus 10 plus 10 plus 20, which is equal to 0. Now what is the thing you are getting? HA plus HD equals
minus 30.
Minus 30. See, this is the third equation. This is the third equation. See, but I don't know HA, HD. If I express the HA and HD in terms of MAB, MBC, MCD and substitute whatever in 6 equation here, you are getting one more equation. That is your sway condition. Then you are having 3 simultaneous equation, 1, 2, and 3. You will solve. You are getting theta B, theta C, and delta. Now, how to arrive HA? They will intentionally ask in your MCQ, what is HA value? What is HD value? ನಾವು MCQ ಮಾಡುವಾಗ ತುಂಬಾ ಕ್ವಶನ್ ಸೆಟ್ ಮಾಡಿದ್ದೀನಿ ಇದ್ರ ಮೇಲೆ, ನಿಮಗೆ ನೆಕ್ಸ್ಟ್ ಬರುತ್ತೆ. ಅವಾಗ ಹೇಳ್ತಾನೆ HA ಮಾತ್ರ ಎಷ್ಟು, HD ಮಾತ್ರ ಎಷ್ಟು, ಈ ತರ ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಬಿಟ್ಟು. ಇವಾಗ ಎನಿ ಐಡಿಯಾ ಹೌ ಟು ಡಿಟರ್ಮೈನ್ HA ವ್ಯಾಲ್ಯೂ? Any idea? See, for HA, which is responsible? Which column is responsible for HA?
AB.
AB. For HD, which column is responsible?
CD.
DC, right? So consider only AB. For HA, consider only AB. So you want HA, right? Where you have to take moment to find HA?
Moment about B.
Yes, take moment about B. Yes, when you take moment about B, how it is rotating HA towards B?
Anti-clockwise.
Anti-clockwise. Minus HA multiplied by perpendicular distance is 4. And this 10, how it is rotating?
Minus 10 into 2.
Minus 10 into 2
Is equal to 0.
And also you have to consider this moment. This one, there is a moment. This is MAB clockwise we are assuming. This is MBA.
AB, sir. MAB.
Plus MAB plus MBA directly, because clockwise equals 0. Now, what is HA you are getting? 10 into minus 20 MAB plus MBA minus 20 which is equal to 4 HA, right? Now, what is HA? HA equals MAB plus MBA minus 20 divided by 4. Any doubts? Similarly, compute HD. Similarly, compute HD. Similarly, compute HD by considering moment about C. ಸೇಮ್ ಇದೇನಿಲ್ಲಪ್ಪ, ಇದೇನ್ ಮಾಡಿದೆ, ಈ ಮೆಂಬರ್ ತೆಗೆದ್ಬಿಡು, ಇದನ್ನ ಮಾತ್ರ ಕನ್ಸಿಡರ್ ಮಾಡು, ಆಯ್ತಾ? ಇವಾಗ ಈ ಮೆಂಬರ್ ಮಾತ್ರ ಇದು ಮೊಮೆಂಟ್ ತಗೋ ಅಷ್ಟೇ. ಇದನ್ನೇ ನಾನು ಮತ್ತೆ ಬರ್ದಿರೋದು, ಇದೇನ್ ಬರೆಯೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ನಾನು ಸುಮ್ಮನೆ ನಿಮಗೆ ತೋರಿಸಿದೀನಿ. ದೇರ್ ಇಸ್ ನೋ ಅದರ್ ಕನ್ಫ್ಯೂಷನ್ಸ್. ನೋಡಿ, ಈ ಮೆಂಬರ್ ಅಲ್ಲಿ MB = 0 ತಗೊಂಡ್ರೆ ಏನ್ ಬಂತು? ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ HA into 4. ಸೊ minus HA into 4. ಇದು ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್, therefore minus 10 into 2. And ಇಲ್ಲಿ there are two moments, MAB plus MBA plus MAB plus MBA equals 0. So you are getting HA. Similarly, what is the value of HD? What is the value of HD?
MDC plus MCD divided by 3.
MDC plus
MCD
divided by
3, sir.
3. ನಾವು ನೀವು ಇಷ್ಟೆಲ್ಲ ಸಾಹಸ ಮಾಡೋದ್ ಬೇಡ. ನಿಮ್ಗೆ ಇವಾಗ ಸುಮ್ನೆ ಒಂದ್ ಲಾಜಿಕ್ ಕೇಳ್ಕೊಡ್ತೀನಿ, ಅದನ್ನ ತಲೆಯಲ್ಲಿ ಇಟ್ಕೊಂಡ್ರೆ ಸಾಕು. ನೀವು ಡೈರೆಕ್ಟ್ ಆಗಿ HA HD ವ್ಯಾಲ್ಯೂ ಬರಿಬಹುದು. ಏನಿಲ್ಲ, ನೀವು ಏನ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು? ಈ ಈಕ್ವೇಶನ್ ಫಸ್ಟ್ ನೋಡಿ. ಇಲ್ಲಿ ಏನ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ಬೋದು? ವಾಟ್ ಇಸ್ ದಿಸ್? ದಿಸ್ ಇಸ್ ದ ಸಮೇಷನ್ ಆಫ್ ಮೊಮೆಂಟ್ಸ್ divided by what is this 3?
Length of the member.
Height of the member. So height of the member. So H horizontal reaction HD is nothing but summation of moments divided by height. Here also you see, what is AB? What is MAB? MAB is the moment. What is MBA? MBA is also moment. What is this 20? This 20 is also a moment. Why it is these two are clockwise, positive with respect to B. This is anti-clockwise. That's why minus 20. So the only thing you have to remember is the horizontal reaction is equal to summation of moments with respect to top point, with respect to column malla, bottom of the column malla, top of the column point divided by height of the column. Height of the column. See, ನನಗೆ ಇವಾಗ ಅದೇನು ಬೇಡ, ನನಗೆ ಈಗ ಸಿಂಪಲ್ ಇಲ್ಲ, ಇನ್ನೊಂದು ಇಲ್ಲೇ ಪ್ರಾಬ್ಲಮ್ ಹೇಳ್ತೀನಿ, ಅಲ್ಲಿ ನೀವು ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ಬೋದು, ಇಷ್ಟೆಲ್ಲ ನೀವು ಸಾಹಸ ಮಾಡೋ ಅವಶ್ಯಕತೆನೇ ಇಲ್ಲ. In all rectilinear frames, we know that we are getting HA and HD or HB, whatever it may be the value. Now tell me, I have given like this, and given like this hinge. I have given here P, and I have given here P1, A, B, C, D. Here also A will develop HA. What is the value of HA and what is the value of HD for this given problem? Now just see, when you're considering HA, you know that here AB will come, here BA will come, MAB, MBA. So MAB plus MBA. And there is any other loads on this member? There is no load on member, right? There is no other loads on this member. There is no other loads on this member. Therefore, divided by H1 over. It is over. Next, come to this. Here, take the moment here. This is clockwise. Therefore, HD equals MCD plus MDC. Here, how it is rotating towards this P, say L by 2. How it is rotating towards C? Clockwise or anti-clockwise?
Clockwise.
So plus P into L by 2 over divided by H2. Understand? Any doubts? See, I will give one more example because this is very, very important. Pakka question on this shear condition. ನೀವೇ ಹೇಳ್ಬೇಕು ಇವಾಗ. I will give simple. Yes, for this, what is HA? For this, what is HA?
MAB plus MBA divided by L.
See, I will give this is H1, this is H2. What is HA?
MBA plus MB.
Sorry, MAB plus MBA
divided by H1. What is HD? MCD plus MDC divided by H2. Now, I will add one small load here, say 10 at 2 meter and 1 meter. Now tell me what is HA? What is HA? What is HA? HA
MAB plus
MAB plus MBA, and what is the moment with respect to B?
plus 20.
Plus 20 divided by, what is the height now?
3
over. Now what I will do, I will give the here 10, 1 meter, 2 meter, 1 meter, 1 meter. Now what is HD? What is HD? What is HD? This is 10, 1 meter, 1 meter. What is HD? MCD plus MDC. This is plus or minus towards C?
minus
10.
10.
10 into 1, 10 divided by
2.
2. Any doubts? Any doubts?
No, sir.
This is very, very important. ಈಗ ನಾನು ಇದೆಲ್ಲ ನಿಮ್ಗೆ ಸ್ಟೆಪ್ಸ್, ಈ ಸ್ಟೆಪ್ಸ್ ಅಲ್ಲೇ ಇದೆಲ್ಲ ಬರೋದು, ಇದ್ರಲ್ಲೇ MCQ ಬರೋದು ನಿಮ್ಗೆ. ಬೇರೆ ಇನ್ನೇನು ಚಾನ್ಸೇ ಇಲ್ಲ ಕೇಳೋದಕ್ಕೆ. ಅವನು ಇದನ್ನೇ ಸೆಟ್ ಮಾಡಿದಾಗ ನಿಮ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಅಂದ್ರೆ ಬೇಸಿಕ್ ಗೊತ್ತಿರಬೇಕು. ಬೇಸಿಕ್ ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ ಕೊಲ್ಯಾಪ್ಸ್ ಆಗೋಗುತ್ತೆ. ನಾವು 2 kilonewton meter, 4 meter. Now tell me, what is HA, AB? What is HA?
MAB plus MBA.
Yes. MAB plus MBA?
Minus 8 by 2.
Minus 16.
Minus?
Minus 16 by 4.
Minus 16 divided by
4.
4. Just convert it into point load. When you are converting it into point load, 4 2s are 8. Accept 2 meter, 2 meter. Please consider a moment here. It will rotate anti-clockwise. So what you are getting? HA equals MAB plus MBA. So minus 16 divided by 4. Any doubts? Any doubts? Clear? Now tell me what I will do now. I will ask like, what is the sway condition? What is the sway condition? For sway condition, what you have to do? This is the sway condition. HA plus HD equals minus 30 is the sway condition. So you know HA value, you know HD value, which is equal to minus 30. Likewise, you tell me, what is the sway condition for this beam? 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 What is the sway condition for given beam?
HA plus HB minus 40 is equal to 0.
Yes, this is HA positive. So if you take this like this, so HA plus 10 minus 50 plus HD equals 0. So HA plus HD equals to 40. Minus 40 you are getting. If you take on right side, it will become plus 40. So nimge ishte kelbodu, idunne nimge optional hakbodu. So any doubts? Any doubts? Now what I will do, I will add one more force like this now. For the same thing, I will add one more load here, UDL, of 2 kilonewton per meter at 4 meter distance. Now what is your sway condition? What is your sway condition? What is the sway condition? Last ಹೇಳಿದ್ರಲ್ಲ ಏನು? ಇಲ್ಲೊಂದು ಫೋರ್ಸ್ ಇದೆ, ಇಲ್ಲೊಂದು ಫೋರ್ಸ್ ಇದೆ. HA minus 10. It is acting, this is plus 10. HA plus 10. It is acting minus 2 into 4, 8. Minus 50 plus HD equals 0. Just point to convert ಮಾಡ್ಕೊಳ್ಳಿ. What is HA plus HD? HA plus HD minus 58. 48. So equal 48. Any doubts? Any doubts? See, ಈ ತರನೇ ಕೇಳೋದು sway condition or shear condition. What is the shear condition of the given frame structure? ಇದನ್ನ ಆಪ್ಷನ್ ಅಲ್ಲಿ ಕೊಟ್ಟಿರ್ತಾನೆ. HAHD ಅಂತಾನೂ ಕೊಡಲ್ಲ. ನೀವು ಫೈಂಡ್ ಔಟ್ ಮಾಡೋ ಈ ತರ ಕೊಟ್ಟಿರ್ತಾನೆ, MAB plus MBA ಅಂತ ಎಲ್ಲ. Yes, ಈ ತರ ಆಪ್ಷನ್ ಅಲ್ಲಿ ಹೇಳಿ, what is HA now for this member? What is HA for this member now?
MAB plus MBA.
Okay. ಆಮೇಲೆ
Plus 16.
Very good. Plus 16
by 4.
Very good. Similarly, what is HD?
MCB plus MDC.
MBC, I will give 2 meter distance. Divide by 2 equal 48. That is the shear condition or sway condition. Any doubts? I will give one more problem, the last problem. If you are finding this problem, then I can move to moment distribution method. So any doubts in slope deflection method? Only this. There is nothing in the slope deflection method. See, don't bother hinge or whatever fixed, both are same because it will not allow to move translation. That's all. Now tell me what is HA, HD and sway. I will give one load also. 10 kilonewton, 2 meter, 1 meter, and I am giving some partial load. ಈ ತರ ಎಲ್ಲ ಕೊಡಬೇಕು ನಿಮಗೆ ಚೆನ್ನಾಗಿ ಮಾಡಬೇಕು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು ಇದೆಲ್ಲ this is 2 kilonewton per meter ಇಲ್ಲೇನ್ ಕೊಡೋದು ಯೂಸ್ ಇಲ್ಲ this is 1 meter, this is 1.5 meter, this is 1 kilonewton per meter, this is 2 kilonewton per meter. Now tell me what is sway condition. First, what is HA? What is determine HA? This is A, and I will give one joint load also. Here I am mentioning joint load of 10 kilonewton. Here also I am giving a joint load like this in positive direction, 2 kilonewton. What is HA? What is A, B, C, D? What is HD? And what is sway condition? It's a last problem. It's a very simple problem. Yes, first tell me what is HA. I will write here. What is HA? What is HA?
Sir, it will be -5.
Okay.
-5 plus
Hello, first,
MAB.
First tell me AB, MAB, MB. Afterwards, I will take -5 and all. What is HA? HA equals?
MAB.
MAB.
Plus MBA.
Plus MBA.
-5.
-5.
Divided by 3.
Divided by 3. What is HB? What is HD? Please check all of you HA. Any other answers HA?
Sir, MAB plus MBA plus 5.
Plus 5. Okay. Divided by 3.
Minus
Any
4.
other answers?
No, sir. Minus 4.4 should also come.
Minus?
4.4.
Minus 4.4. Okay.
Yes, sir.
Okay.
UDL should be converted now, sir.
Yes, if UDL should be converted, then it will become 2 into 1. It will be 2 into 1 is 2 kilonewton. 2 kilonewton at 0.5 meter and 0.5 meter.
Yes.
So when you take this moment,
and plus 2.
the total is 2.5 meters. So if you
Yes,
take
sir. It
the
will be
moment
4.4.
over here, so it will become like, I'll write here, this is right. Only this is rotating clockwise. So plus, rotating clockwise. That's why plus. Why it is plus? Because with respect to B, how it is rotating? It is rotating clockwise. So plus 2 into 0.5 plus 2, 2.5. But this is rotating anti-clockwise. Minus 10 into 2. How much you are getting?
-15.
Minus? So you are getting MAB plus MBA This is how much? 2.5 into 2 is 5. So minus 15, right? Minus 15 by 3. See, any doubts here? Any doubts here? Clear? Just convert into point or take a moment. Now, this one. What is HD? What is HD? What is HD? See, don't think that, sir, hingella kodalva. No one knows. It's in a competitive exam. ಈ ತರ ಎಲ್ಲ ಮಾಡಿದ್ರೆ ಅದೆಲ್ಲ ನಿಮ್ಗೆ ತುಂಬಾ ಈಸಿ ಆಗುತ್ತೆ. ನನ್ಗೇನಿಲ್ಲ, ನನಗೆ ತುಂಬಾ ಈಸಿಯಾಗಿ ಸಣ್ಣ ಪುಟ್ಟ ಹೇಳ್ಕೊಟ್ಬಿಟ್ಟು ಹೋಗ್ಬಿಡ್ಬೋದು. ನನ್ಗೇನು ಆಯ್ತು ಸೂಪರ್ ಸರ್ ಅಂತೀರಾ? ನಥಿಂಗ್. ಯು ಹ್ಯಾವ್ ಟು ಲರ್ನ್ ದಿ ಸಬ್ಜೆಕ್ಟ್. It's very, very important. If you learn the subject with basics, you can solve whatever the kind of problem. Next, ಈಗ ಇದಾದ್ಮೇಲೆ ಒಂದು 5 minutes break ಕೊಡ್ತೀನಿ. ಆಮೇಲೆ ಅಂತೂ ಕ್ಲಾಸ್ ಮಿಸ್ ಮಾಡ್ಕೋಬೇಡಿ. ಮೊಮೆಂಟ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಮೆಥಡ್ ಅದ್ರಲ್ಲಿ ತುಂಬಾ ಬೇಸಿಕ್ಸ್ ಬರುತ್ತೆ. ಅದನ್ನ ಹೇಳ್ಬಿಟ್ಟು ಒಟ್ಟಿಗೆ MCQ ಮಾಡ್ಬಿಡೋಣ, SD and MD ಮೆಥಡ್. ಯಾಕೆಂದ್ರೆ ಎರಡೂನು ಈಸಿನೇ ಇದೆ. ನಿಮ್ಗೆ ಇದು ಬರಲಿಲ್ಲ ಅದ್ ಬರಲ್ಲ, ಅದ್ ಬರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ಇದು ಬರಲ್ಲ. Both are interrelated. Okay? Yes, what is HD?
MCD plus MDC plus 2.875.
ಈಗ ಒಂದೊಂದ್ರದೇ ಮೊಮೆಂಟ್ ಹೇಳಿ. ಇದನ್ನ ಪಾಯಿಂಟ್ ಲೋಡ್ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ ಏನಾಗತ್ತಪ್ಪ? ಇದು 1 into 1.5. ಸೊ 1.5. 1.5 by 2 ಅಂದ್ರೆ 0.75. ಸರಿನಾ? 0.75. ಇದನ್ನ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ರೆ 2 into 1 2.5 ಅಲ್ವಾ? ಟೋಟಲ್ ಇಲ್ಲಿಂದ ತಗೊಂಡ್ರೆ the distance is 1.5 plus 0.5 2 meter. This distance is 0.75. ಅಷ್ಟೇ ಬೇಕಾಗಿರೋದು. ಇವಾಗ ಮೊಮೆಂಟ್ ಬರೀರಿ. So how, with respect to C, how 1.5 will rotate? Anti-clockwise. So minus 1.5 into 0.75. How this 2 will rotate?
Clockwise.
Plus 2 into 2 divided by, what is the length?
2.5.
Now tell me, MCD
plus MDC
plus MDC
plus 2.875.
2.875 divided by
2.5.
This is over. Now tell me, what is the sway condition? This is over. What is the sway condition? For sway condition, what you have to do? Sigma H equals 0. If you take sigma H equals 0, what you are getting?
HA plus HD.
Here you are having HA. Here you are having HD. Okay. HA plus HD.
Plus
HA plus
10.
HD.
Plus 10.
Plus 10.
Plus 10.
Plus 2.
10.
Minus 2.
Minus 2.
Plus 2, sir.
Plus 2 or minus 2? Plus
Both,
2,
sir. Minus 2 and plus 2.
Minus 2 and plus 2. Why minus 2 and plus 2?
Sir, UDL is there, no, sir.
This is minus 2, okay.
C is having plus 2.
Right?
And C is having plus 2, sir.
Oh, this one, very good. Okay. Okay, plus 2.
Minus 2, sir.
Plus 1.5.
Minus 2.
Minus 2.
Yes, sir. Plus, okay, sir. Over.
That's all, which is equal to 0. How much you are getting? HA plus HD equals? Yes, sometime ನೀವು ಈಗ ನೋಡಿ, ಈಗ ನನಗೆ ನಾನೇ ಬರ್ದಿರೋ 2 ಕಿಲೋಮೀಟರ್ ನನಗೆ ನಾನೇ ತಲೆ ಕಾಣಿಸ್ತಾ ಇರಲಿಲ್ಲ. ಈ ತರ ಸೈಟ್ ಎರರ್ ಆಗ್ಬಿಡುತ್ತೆ. ಸೊ ಏನು ಮಾಡಕ್ಕಾಗಲ್ಲ. ಅದನ್ನೆಲ್ಲ ನೀವು ಒಂದ್ ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಆಗಿ ನೋಡಿ, 2 ಸಲ ನೋಡಿ, ಆಮೇಲೆ ಆಪ್ಷನ್ಸ್ ಹೋಗ್ಬೇಕು. ಓಕೆ. ಹೌ ಮಚ್ HA plus HD? 10 plus 10 20 22 23.5. This and this will cancel. Sarina, minus 23.5. Check. Is it right?
Sir, minus 2 hang cancel.
Minus 2 minus not. Minus 2 plus 2 will get cancelled. So now, how much you are getting?
19.5. 19.
Minus 19.5.
Minus 19.5.
Plus.
Okay.
Yes, sir. 9.
Plus 19.5.
No. If you take on the right side, it will become minus, right?
Yes. Yes, sir.
Is right. See, this is way condition. ಅವನು ಏನ್ ಮಾಡ್ತಾನೆ ನಿಮ್ಗೆ ಆಪ್ಷನ್ ಅಲ್ಲಿ HA ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಇದನ್ನು ಹಾಕಿ HD ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಇದನ್ನು ಹಾಕಿ ಇದನ್ನು ಕೊಡ್ಬೋದು. ನೀವು ಆಗ ಇಷ್ಟನ್ನು ಮಾಡ್ಕೋಬೇಕಾಗತ್ತೆ. ಇಷ್ಟನ್ನು ಮಾಡೋದಕ್ಕೆ ಹಾರ್ಡ್ಲಿ ಯು ಆರ್ ಟೇಕಿಂಗ್ 1 minute or 1.5 minutes. ಓಕೆ, ಆಮೇಲೆ ಇನ್ನೊಂದು ಏನ್ ಗೊತ್ತಾ, ಕ್ವಶನ್ ನಿಮ್ಗೆ ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿದ್ರೆ ಜಡ್ಜ್ ಮಾಡ್ಬೋದು MCQ ನಲ್ಲಿ ಇದೇ ಸರಿ ಇದೇ ತಪ್ಪು ಅಂತ. ಯಾಕೆಂದ್ರೆ ಅವ್ನು ಏನ್ ಮಾಡ್ತಾನೆ ಗೊತ್ತಾ, ಇಲ್ಲಿ ಪ್ಲಸ್ ಮೈನಸ್ ಹಾಕ್ಬಿಟ್ಟಿರ್ತಾನೆ, ಅಲ್ಲೇ ನಿಮ್ಗೆ ಗೊತ್ತಾಗೋಗುತ್ತೆ. ಓ BC ಎಲಿಮಿನೇಟ್ ಆಯ್ತು, ಡಿನೇ ಇದಕ್ಕೆ ಆನ್ಸರ್, ಇದು ಆಯ್ತು, ಇದಕ್ಕೆ ಇದೇ ಆನ್ಸರ್ ಅಂತ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ ಮಾಡ್ಬೇಕಾದ್ರೆ. ಓಕೆ, ಕ್ಲಿಯರ್? ಓಕೆ, ಟೇಕ್ 5 minutes of break. Exactly at 8 or 8:02 we will start moment distribution method. This is enough for slope deflection method. See, what is the thing? You got all 3 equations, right? This is the 3 equation, third equation. By solving 1, 2, 3 equation, you are getting the value of theta B, theta C and delta. What finally you are doing? You are going to substitute this in slope deflection equation. SD of 6 equations you are having. So finally you are getting the final moments, MAB, MBA and all. Finally you are drawing a BMD, bending moment diagram. That is the method. For this method, you in your theory, you are getting 20 marks. This is a very simple one. But here, we must know the concept to solve MCQ. That's all. Clear? Any doubts in ST method? I hope all of you getting ST method. Okay? Is
Yes,
it
sir.
okay?
Yes, sir.
Yes, sir.
Very good. We take a 5 minutes of break. Come back. We'll go for moment distribution method. After this, we will solve both MD and ST method MCQs in one class. Nothing to worry about the MCQ part. Okay? Take a 5 minutes of break. Before going to moment distribution method, in this particular method, there are a few technical terms associated with this method. The technical terms are majorly relative stiffness, distribution factor, carryover moment, balance. There are so many technical terms, but nothing to worry about those terms. Generally, if you know the concept, then those are the terms. If they ask carryover moment, we can compute which member carryover moment is required. And if they are asking distribution factor, we can compute which member is expecting distribution factor and all the things. So I hope you are well versed with the slope deflection method. Let me move on to moment distribution method. I will give a few basic tips. Then we will move on to MCQ question. Simultaneously, I will giving some hints what are the expected type of MCQs in each and every part of the method. Okay. Moment distribution method. This is very, very important method and very, very simple method. It's called MD method. Previous one is SD method. MD method. See, the name itself indicates that moment distribution. We are doing the moment distribution in this particular method to arrive the final moments. Okay. So by not wasting the time, we will move on directly to this particular method. What is meant by moment distribution and how we are going to solve the problems and all the things. I will move on to steps involved to solve the problem. To solve numericals. Okay. See, the very first step here also, kinematic indeterminacy. See, this particular method is also applicable for both beams and frames. Okay. So we know that how to determine kinematic indeterminacy and all. So I'll consider a simple beam for understanding purpose. Later on, we move on to some complicated frames and all. Okay. Just tell me, you know that what is the kinematic indeterminacy of the given beam?
2, sir.
2. Theta B, theta C. You know that. Okay. So we can skip this particular step because we know the thing. Okay. The second is FEM. Same thing. Fixed end moments. See, if I put UDL, And if I put eccentric, say here I will put like W L1, here W A B. L2. Total is L2. So what is the FEM? We know that. What is MAB? What is MFAB?
It's WL square by 12.
WL square by 12.
WL1 square by 12.
Yes, WAB by L2 square, or WAB square. For this, WAB square by L square, L2 square. For this, WBA square by L2 square. You know that. Plus or minus, depending on sign, we just use the thing. Or I will assign the values. Then it will very easy to assign time. We'll give 2 kilonewton per meter. I will give once again 3 kilonewton. For 4 meter, I will give 2 meter, 4 meter. It's very easy. EI I will vary here because to understanding, I will take this 2 EI and I will take for this member 2 EI. A, B, and C. Okay. So FEM is also known. I am not concentrating on that particular step. The third step is very important step. This is the major step. So one sure question from this particular step. Okay. That is called distribution factor. The third step is distribution factor. But for computing distribution factor, we must know the relative stiffness. That's why I am not writing that particular distribution factor first. I'll take relative stiffness. But the step is distribution factor. To know the distribution factor, we must require relative stiffness. So that's why I have taken relative stiffness. See, for when you are computing relative stiffness, please remember one simple tip. That is one simple thing. See, if the beam is like this, say like this, A, B, C, D. See here in this beam, how many spans?
3.
3 spans. What are those?
A, B, B, C, C, D.
A, B, B, C, C, D. Out of 3 span, how many end spans? How many end spans? End. How many end spans?
2.
2. What are those?
AB and CD.
AB and CD. What is BC?
It's middle span.
What is BC?
Middle span.
Intermediate span. BC is
Intermediate.
Intermediate span. Out of this is end span. And this is also end span. So this is middle span or intermediate span. Intermediate span. Okay. See, please remember while you are writing relative stiffness, please remember one simple condition. If the end span, is simply supported, if the end span is simply supported, then relative stiffness or not relative stiffness, you take stiffness is given by 3EI by L. Please take this 3EI by L. Very important. You have to remember for remaining all conditions, for 4EI by L. 4EI by L. Now tell me here in the given example, which end span is having simply supported end?
CD.
CD. Hence CD is what?
3EI by L.
Remaining any end span is simply supported?
4EI by L.
So remaining all, this is intermediate, not end span, 4EI by L. This is also not end span, 4EI by L. Any doubts?
No, sir.
You have to remember this. That's all. If you know this, you are through. Nothing to worry about some other things. If some alteration, I will help how to do alteration. But this is very, very important. So any doubts? Now, tell me what is the relative stiffness for given beam?
Where's
For here, this one, given beam.
4EI by L for AB?
I have given value, just substitute. How much you are getting relative stiffness for this? This is simply supported. What is this? If simply supported, and this is not simply supported. So this is 3EI by L. What is EI?
2EI.
2. 3 into 2, 6 EI.
6.
By L is 6.
6.
Then how much you are getting?
Just EIs.
Just EI. Here?
4EI by L.
Here?
Just
4 EI by L. 4 EI by 4. How much you are getting? EI.
EI.
Yes, sir.
Any doubts? Any doubts? Generally, this is 3 EI by L. And this is 4 EI by L. Now substitute the EI value. You are getting EI. Here also you are getting EI. EI. Any doubts? Any doubts? Any doubts? This is relative stiffness. This is not full stiffness. This is relative stiffness. This is relative stiffness. Whatever we are writing, this is relative stiffness. Finally, we require K. K is nothing but, see, K of the B joint. K of the joint, B joint is nothing but KBA plus KBC. So EI plus EI is 2. What is the relative stiffness of joint B? That is BA plus BC. How much?
2
2.
EI.
What is the relative stiffness of joint C?
Only EI.
CB. Only EI. 1.
Yes, sir.
These are the MCQ. You may expect. What is the stiffness? Now I will give one problem. I will give a simple thing. What is the stiffness of joint B? I will give, this is 1.5i and 2i. What is the stiffness of joint B? Stiffness is indicated by K. What is KB? Determine the stiffness of B. B joint. B joint. Joint B.
Length, sir.
Yes.
Length ಕೊಟ್ಟಿಲ್ಲ sir.
For both, what is the condition?
4 EI by L.
4 EI by L. For this, 4 EI by L. This is also 4 EI by L. Right? So now, here 1.5. So 4 into 1.5 EI by L. This is also 4 into 2 EI by L. How much? 4 into 1.5? 6. Ishto? How much?
6.
6 EI by L. This is 8 EI by L. What is the summation? What is the summation?
14 EI by
14
L.
EI by L. KB equals
14 EI by L.
14 EI by L. They may ask in MCQ. They will give different answer. 7 EI by L, 8 EI by L, 14 EI by L, 6 EI by L. You have to pick the correct one. These are the things you are expected. Any doubts? Any doubts in stiffness?
No, sir.
I will give one more example. Please try to find this. I, 3I, 0.5I. What is the stiffness of joint C? What is the stiffness of joint C? What is KC? See, don't use, you just tell me, when I am talking about C, what are the adjacent member related to joint C?
BC.
CB and
CD.
CB and CD. What CD and CB are which kind of span? Whether it is intermediate span or end span?
Intermediate.
Intermediate. For intermediate, what is the relative stiffness?
4EI well.
For both 4EI by L, 4EI by L. Here also there is no simple support. 4EI by L, 4EI by L. Beam ಬರ್ಕೊಂಡು ಅದ್ರ ಕೆಳಗಡೆ ಬರ್ಕೊಂಡು ಹೋಗ್ರಪ್ಪ. This is 4EI by L. This is 4EI by L. This is also 4EI by L. This is also 4EI by L. So here 4 into 2, 8EI by L. Here 4EI by L. Here 4 into 3, 12EI by L. Here 4 into 0.5, 2EI by L. Now I am asking for C. Do this sum. How much? 16EI by L. What is joint D? What is KD? How much KD? For KD, what you have to do? Do the sum.
14EI by L.
14EI by L. For joint B. For joint B. 12EI by L. ಯಾವ್ದನ್ನಾರು ಕೇಳ್ಬೋದು. Any doubts?
No, sir.
So for intermediate span, we will take it as 4 times of EI by L.
Yes.
No, so?
Yes. If only,
Okay,
please observe the equation. If the end span, only end span, remaining all 4EI by L. Clear?
Okay. Okay, sir.
Okay, I will give one more example because it's a very, very important topic. What is KB? What is KA? And what is KC?
Sir, KB is 15 EI by L.
KB is
15 EI by L.
okay. Right. Others, any other answers? What is KA?
15 EI by L KB.
Yes, right, 15. Because what is KA? What is KA? This is 3EI by L.
EI by L.
This is also 3EI by L because both are end span. So 3 into 2, 6 EI by L. 3 into 3, 9 EI by L. So if you do this sum, we are getting 15 EI by L. So that is right. What about A? What about A? This is 3 EI by L. 3 into 2. What?
6 EI by L.
Here, this is 3 EI by L. 3 into 3.
9 EI by L.
9 EI by L. This is stiffness. Any doubts? Clear? Shall I move on to next step? Yes.
Yes.
What I will do now, I will set a one important MCQ question now. What are the relative stiffness in members? All members. I will give 4 options. You have to guess the options.
Sir, EI value?
Sir, EI value mentioned.
EI value is same. I am not altering EI value. You have to guess any one. I will write 3 or 4 options. You have to guess any one option.
Yes, sir.
Okay.
Yes, sir.
Yes. Which one is correct option?
Option B.
Option B. Any other options? Yes. What is this? What is this?
3
4 EI by
4 EI by L.
L. What is this?
4 EI by L.
4 EI by L.
What is this?
3
3
EI
EI
by
by L.
See, if you divide by 4, what is you are getting? If you divide by 4,
EI by
EI by L or I by L, EI by L or I by L, 3 by 4, EI by L. Which option is correct?
B.
See, like this, ಈಗಲೂ ಸೆಟ್ ಮಾಡಬಹುದು. ನೀವು ಸರ್ ನಮಗೆ ನೀವು 3i ಹೇಳಿದ್ರಿ 4i ಹೇಳಿದ್ರಿ ಅಲ್ಲಿ ಏನು ಆತರ ಆಪ್ಷನ್ ಇರಲಿಲ್ಲ ಅದಕ್ಕೆ ಬಿಟ್ಬಿಟ್ಬಿಟ್ವಿ ಗ್ರೇಸ್ ಕೊಡ್ತಾರಾ ಅಂತ ಕೇಳಬಾರ್ದು.
Okay, sir.
Clear? Any doubts? So you can remember like this way also. If you refer some textbooks, ಯಾರು ನೀವು ಎಸ್ಸೆ ಮಾಡ್ಬೇಕಾದ್ರೆ ನೋಡಿರ್ಬೋದು ಅವರು 4ei by L 3i by L ನಿಮ್ಗೆ ನಾನು 4 ಮತ್ತೆ 3 ನೀವು ನೆನ್ಪಿಟ್ಕೋಬಹುದು ಈಸಿಯಾಗಿ ಅಂತ ಈ ತರ ನಿಮ್ಗೆ ಮಾಡಿಸ್ದೆ. ಇದು ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋಕೆ ಈಸಿ ಅಲ್ವಾ? 3ei 4ei ನೆನ್ಪಿಟ್ಕೊಳ್ಳೋಕೆ ತುಂಬಾ ಈಸಿ. ಆ ತರ ಮಾಡಿಸ್ದೆ. ಆದ್ರೆ ಕೆಲವರು ಯಾವ ತರ ಡಿಫೈನ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ if your end support is simply supported, that is 3 by 4 times of ei. If your other than this ei ಅಂತ ಹೇಳ್ತಾರೆ. ಅದಕ್ಕೆ ನೀವು ನೋಡಿರ್ಬೋದು ಕೆಲವರು ಇದಕ್ಕೆ ಈ ತರ ಬಂದ್ರೆ i ಅಂತ ಹೇಳ್ತಾರೆ, ಈ ತರ ಬಂದ್ರೆ 3 by 4 times of i ಅಂತ ಹೇಳ್ತಾರೆ. ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಿರೋ ಇಲ್ವೋ ನಂಗೆ ಗೊತ್ತಿಲ್ಲ. ಸೊ ನಾನೇನ್ ಮಾಡ್ತೀನಿ, ಸಿಂಪ್ಲಿಫೈ 4ei by L and this is 3ei by L. ಸೊ ನೀವು ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ what you are getting the same answers.
Yes, sir.
Clear? Any doubts? So ಈ ತರ ಕೇಳ್ತೀವಿ, ಈ ತರ ಕೇಳ್ಬೋದು. This option is right. Second option. ಸೊ ನಿಮ್ಗೆ ಆ ತರ ಯಾವುದೇ ತರ ಬೇಕಾದ್ರೂ ಆಪ್ಷನ್ಸ್ ಬರ್ಬೋದು. ನೀವು ಅಲ್ಲೇ ಡಿವೈಡ್ ಮಾಡಿ ಗೊತ್ತಾಗ್ಬಿಡುತ್ತೆ ನಿಮ್ಗೆ. ಐದರ್ ಅವನು 3 ಇಂದ ಡಿವೈಡ್ ಮಾಡ್ಕೋಬಹುದು. ಇದನ್ನ 3 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಸೇಮ್ ಆಪ್ಷನ್ ಬರುತ್ತೆ. 3 ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ei by L, ಬಟ್ ಇಲ್ಲಿ 4 by 3 ei by L.
4 by 3.
ಆ ತರನು ಕೇಳ್ಬೋದು ಆಪ್ಷನ್ ಅಲ್ಲಿ. ನೀವು ಫಸ್ಟ್ ನಿಮಗೆ ಗೊತ್ತಿರೋದನ್ನ ಬರ್ಕೊಂಬಿಡಿ, ಆಮೇಲೆ ಆಪ್ಷನ್ ನೋಡಿ, ಆಮೇಲೆ ಏನಾರು ಒಂದು ಟ್ರಯಲ್ ಅಂಡ್ ಎರರ್ ಮೆಥಡ್ ಮಾಡ್ಬಿಟ್ಟು ಹುಡುಕಿ, ಬಂದ್ರೆ ಸರಿ, ಇಲ್ಲ ಅಂದ್ರೆ ನನ್ ಆಫ್ ದಿಸ್. Clear? Any doubts? Any doubts in relative stiffness? Any doubts in relative stiffness? We have solved so many problems. Any doubts in relative stiffness? Now I am going to distribution factor. Any doubts in relative stiffness? ಇನ್ನೊಂದು ಏನಾದ್ರು ಪ್ರಾಬ್ಲಮ್ ಕೊಡ್ಬೇಕಾ ಇಲ್ಲ ನಾನು ಡೈರೆಕ್ಟ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಫ್ಯಾಕ್ಟರ್ ಹೋಗ್ಲಾ?
No sir, no doubt.
No doubts.
No
No
doubt,
doubts.
sir.
Very good. Okay. Next, fourth step, that is distribution factor. Yeah. See, the given beam is like this alwa. Hingide alla kottiro beam ishte tan kottirodu
UDL.
A, B, C. Load ಬಗ್ಗೆ ಅಂತಲ್ಲ ಕೆಡಿಸ್ಕೋಬೇಡಿ. Your distribution factor is not also related to load. This is a different one. Okay. Now you just take like this joint. See, please remember, distribution factor at fixed end is 0. ಇದನ್ನೇ ಡೈರೆಕ್ಟ್ ಆಗಿ ಎತ್ತಾಕ್ಬೋದು. What is the distribution factor at fixed end? The distribution factor at fixed end is 0. ಒಂದ್ ಎರಡು ಪಾಯಿಂಟ್ ಬರ್ಕೊಡಿ. Distribution factor at ಇದನ್ನೇ ಡೈರೆಕ್ಟ್ ಆಗಿ ಎತ್ತಾಕ್ಬೋದು. Distribution factor at fixed end is 0. Distribution factor at roller, ಆಮೇಲೆ ಇನ್ನೊಂದು, ಇಫ್ ದ ಎಂಡ್ ಸಪೋರ್ಟ್ ಮಧ್ಯೆ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಅಲ್ಲಿ ರೋಲರ್ ಸಿಂಪಲ್ ಬಂತು ಅಂತ ಒಂದ್ ಹಾಕ್ಬಿಟ್ಟಿರ. ಆಮೇಲೆ ಇಫ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಫ್ಯಾಕ್ಟರ್ ಅಟ್ ಎಂಡ್ ಸಪೋರ್ಟ್ ಈಸ್ ಸಿಂಪಲ್, ರೋಲರ್ ಆರ್ ಹಿಂಜ್, ದಟ್ ಈಸ್ ಯೂನಿಟಿ 1. ಇವಾಗ ಎಂಡ್ ಸಪೋರ್ಟ್ ನೋಡಿ, ಇಲ್ಲೂ ಅಷ್ಟೇ ನಿಮಗೆ ಫಿಕ್ಸ್ಡ್ ಸಪೋರ್ಟ್ ಮಧ್ಯದಲ್ಲಿ ಯಾವತ್ತೂ ಬರಲ್ಲ, ಈಗ ಎಂಡೇ ಬರೋದು ಫಿಕ್ಸಿಟಿ. ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಎಂಡ್ ಸಪೋರ್ಟ್ ಈಸ್ ಫಿಕ್ಸ್ಡ್, ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಫ್ಯಾಕ್ಟರ್ ಇಸ್ 0. ಇಫ್ ದ ಎಂಡ್ ಸಪೋರ್ಟ್ ಈಸ್ ಸಿಂಪಲ್, ರೋಲರ್ ಆರ್ ಹಿಂಜ್, distribution factor is 1. Now tell me, in the given beam, what is the distribution factor at A and what is the distribution factor at C?
A is 0.
A is 0.
C is 1.
C is
1.
Now ಯಾವುದು ರಿಮೈನಿಂಗ್ ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕಾಗಿರೋದು? Intermediate.
B.
Distribution factor at intermediate joint. What is the intermediate joint? B. What are the members of intermediate joint? What are the members?
BA and BC.
BA, BC. What is relative stiffness? What is relative stiffness?
For BA, 4A.
For BA?
4 by L.
For BC?
3 by L.
I have given, I think, this is EI and this is 2 EI. 4 meter, 6 meter.
Next slide.
This is EI, right? This is 2I. And this is 4 meter and 6 meter. Now tell me, what is 4 EI by L? 4 into I, 4 by L is 4. So you are getting, what you are getting? What you are getting? 4 EI by L, length is 4. You are getting EI. What is BC we are getting? How much BC? 3 into
6.
2 EI by 6. How much we are getting?
EI by L.
EI. So EI. Now you do sigma K. Do this sum. How much sigma K?
2 EI.
2 EI. Now distribution factor equal K by sigma K. Here these are K. We are having two members, right? So we are getting two distribution factors. EI, K by sigma K. K is 1. EI by 2 EI. How much we are getting? Half, 0.5. Here also EI by 2 EI. How much we are getting? 0.5. So one more thing you have to remember, that the distribution factor at joint is 1, or the summation of distribution factor must be 1 at any joint, the summation should be 1. But in Canny's method, minus 0.5. Ishtonu ಮಾಡ್ಬಿಟ್ಟು minus half of distribution factor ಮಾಡಿದ್ರೆ rotation factor. ಅದನ್ನು ಬೇಕಾದ್ರೆ ನಿಮಗೆ ಕೇಳಬಹುದು. ಕ್ಯಾನಿಸ್ ಅಲ್ಲಿ rotation contribution ಅಂತ ಬರುತ್ತೆ. This is distribution factor. Rotation contribution equal minus half of K by sigma K. ಅವಾಗ ನಿಮಗೆ ಏನು ಸಿಗುತ್ತೆ? minus 0.25 minus 0.25. This is rotation contribution. ನಿಮಗೆ ಇದನ್ನಾರು ಕೇಳಬಹುದು. ಇದು distribution factor, but distribution factor is for this moment distribution method. Rotation factor for Canny's moment distribution method. Rotation factor is used for Canny's moment distribution method. Distribution factor is used for moment distribution method. Or moment distribution method is also called Hardy cross method. Any doubts? Any doubts to determine the distribution factor?
Sir,
Yes?
after ಅಲ್ಲಿ 0.5 ಹೆಂಗ್ ಬಂತು ಸರ್?
K by sigma K. What is K? Or you can take for this KBA by sigma K. What is KBA? KBA is this one.
EI.
K. EI. What is sigma K? 2 EI. EI get cancelled. What is 1 by 2?
0.5.
0.5. Similarly,
got it.
here, what is KBC? EI. What is sigma K?
2 EI.
2 EI. How much you are getting? 0.5.
Got it.
Clear? Now I will give few more questions. You just try to solve. Now you are getting the clarity. Okay. Three meter, 4 meter, 6 meter. Okay, I will give I, 2I, I. Now, what is the distribution factor for joint B? Distribution factor for joint B. D of B, compute madi. And C. What is distribution factor A? What is that about A? A na leno, D na leno?
4A by L 4A.
A nalli eno distribution factor?
0.
0. Why? Fixed. So
Fixed.
distribution factor at fixed end is 0. Here at D, end support is fixed.
1.
0. End support is roller or hinge. That is 1. Now find for B and C. For B and C, you are getting 2, 2. BA, BC. For C, CB, CD. How to find? See, this is the steps. You are here, you are having one intermediate joint, but here you are having 2 intermediate joints. Or ಸರ್ ನಮಗೆ ಆ ಬೆನ್ಸಿನ್ ತರ ಎಲ್ಲ ಬರ್ದಿದ್ದೀರಾ, ನಮಗೆ ತುಂಬಾ ಕಷ್ಟ ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ ಟೇಬಲ್ ಹಾಕೊಂಬಿಡಿ. ನಿಮ್ಗೆ ಟೇಬಲ್ ಅಲ್ಲಿ ತುಂಬಾ ಹೇಳ್ಕೊಟ್ಟಿದ್ದೀನಲ್ಲ ಎಲ್ಲಾದ್ನೂ. ಸೊ ಜಾಯಿಂಟ್, ವಾಟ್ ಆರ್ ದ ಜಾಯಿಂಟ್ಸ್? B and C. Members, what are the members? BA and BC. For C, what are the members? CB and CD. Member is over. Next, afterwards, what you require? Relative stiffness. Relative stiffness. For BA, what is relative stiffness? 4
EI by L.
EI by L is 3. For BC, 4 EI by L. 4 into 2, 8 EI by L is 4. For CB, 4 EI by L, 8 EI by 4. For CD, 3 EI by L, 3 EI by 6 over. Relative stiffness is over. So relative stiffness is called K. Now you require sigma K. Now you require sigma K. For sigma K, you have to do summation. You have to do summation. What is the summation of this joint? BA plus BC. 4 2s are. Therefore, what is 4 by 3 plus 2?
10 by 3.
10 by 3. 10 by 3 is 3.333 R. 3.34 EI. What is the summation for this? 8 by 4 is 2. 2 plus 0.5. 2.5 EI. Please check whether it is right or wrong. Now, what is relative stiffness? What is distribution factor, not rotation factor? What is distribution factor? We are having 4 members, we are getting 4. Distribution factor equals K by sigma K. K is 4 by 3. 4 by 3 divided by 3.34. I think 0.4 or 0.39. Then remaining 1, we know that it must be 0.61. The summation should be 1. 1 by 3.34. 1 divided by 3.34.
0.299.
0.299. Then check this. What is 4 by 3 divided by? Then please check this. 4 by 3 divided by 3.34.
0.399.
0.399. So you can take 0.4. Then check this. 1 divided by 2. This is 2, right? 2. 4 2s are. 2 divided by 3.34. It must be 0.6 only. 2 divided by 3.34. 0.59. Or if you are taking 0.59, then it must be 0.39. Alva. So ಅದಕ್ಕೆ ಯಾವ್ದಾದ್ರೆ ರೌಂಡ್ ಆಫ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ಇದು 0.4. ಅಲ್ಲಿ ನಿಮ್ಗೆ ಯಾವ್ದು ಕೊಟ್ಟಿರ್ತಾನೆ ಆಪ್ಷನ್ ಅಲ್ಲಿ ನೋಡ್ಕೊಂಡು ಹತ್ರ ಇರೋದು ಹಾಕ್ಬೇಕು. How much this? 4 by 8 is 2. 2 divided by 2.5. 0.8. If you are getting then 0.2.
0.8.
Half. 0.5 by 2.5 is 0.2. See, this is very, very important. Idru mere one sure question. Pakka one MCQ question. Any doubts? ನೀವು ಟೇಬಲ್ ಆರು ಹಾಕಿ ಇಲ್ಲ ಈ ಬೆಂಜಿನ್ ಫಾರ್ಮೆಟ್ ಅಲ್ಲಿ ಆರು ಮಾಡಿ ಆಸ್ ಯು ಎರಡನ್ನೂ ಹೇಳಿದೀನಿ. ಅದ್ರಲ್ಲಿ ಏನಿಲ್ಲ. ಇಲ್ಲ ಏನು ಮಾಡಿದ್ರೆ ಸುಮ್ಮನೆ ಬರ್ಕೊಂಡು ಹೋಗಿ. ಎನಿ ಡೌಟ್ಸ್? ಏನಿಲ್ಲ. ರಿಲೇಟಿವ್ ಸ್ಟಿಫ್ನೆಸ್ ಬರೆಯೋದು ಗೊತ್ತು. ಆ ಜಾಯಿಂಟ್ ಗೆ ಸಿಗ್ಮಾ ಕೆ ಮಾಡಿ ಕೆ ಬೈ ಸಿಗ್ಮಾ ಕೆ. ಏನೋ ಡೌಟ್ಸ್ ಇದ್ರೆ ಕೇಳಿ ಹೇಳ್ತೀನಿ. If you are having any doubts, please ask me. This is very, very important. Relative stiffness. ಇದು ಬಂತು ಅಂದ್ರೆ ಇನ್ನೇನಿಲ್ಲ ನಿಮ್ಗೆ. ನೆಕ್ಸ್ಟ್ ಇರೋದು ಜಾಯಿಂಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ಬ್ಯಾಲೆನ್ಸ್ ಅಂದ್ರೆ ಕ್ಯಾರಿ ಓವರ್ ಅಂದ್ರೆ ಏನು ಅಂತ ಹೇಳ್ತೀನಿ. ಕಾನ್ಸೆಪ್ಟ್ ಅಷ್ಟೇ. ಅದಾದ ತಕ್ಷಣ ಇಲ್ಲಿಗೆ ಮುಗೀತು. ಇದು ಇಟ್ ಕಂಪ್ಲೀಟ್ಸ್ ಯುವರ್ ಟೋಟಲ್ SD and MD ಮೆಥಡ್. The only thing is we have to go for few of the MCQ questions. ಈಗ ಆಲ್ರೆಡಿ ನಾನು MCQ ನಿಮ್ಗೆ ಹೇಳ್ಕೊಟ್ಟಿರೋದ್ರಿಂದ ಅಲ್ಲಿ ತುಂಬಾ ಈಸಿ ಆಗುತ್ತೆ. So next we are having one more important concept, that is influence line diagram. Influence line diagram for beams, frames and trusses as well as arches. ಅಷ್ಟೇ ಇರೋದು ನಿಮಗೆ syllabi. That completes your entire AE syllabi of structures. Within 30 hours we completed in detail with all concepts. ಯಾವುದನ್ನು ಜಂಪ್ ಮಾಡಿಲ್ಲ. I covered all 100% syllabi. So any doubts? ಅರ್ಥ ಆಯ್ತಾ? ಅರ್ಥ ಆಗಲಿಲ್ಲ ಅಂದ್ರೆ ಕೇಳಬೇಕು, ನನಗೆ ಗೊತ್ತಾಗಲ್ಲ. ದಿಸ್ ಇಸ್ ಆನ್ಲೈನ್ ಕ್ಲಾಸ್, ಇಟ್ಸ್ ನಾಟ್ ಆಫ್ಲೈನ್. ಇಫ್ ಯು ಆರ್ ಇನ್ ಆಫ್ಲೈನ್, then my focus is in a different way, but it's an online class. I hope you are getting a step. Okay, I will give one more problem. If you are getting the answer for that particular problem, next we are moving to another topic. Okay, any doubts in this? Any doubts? ನನಗೆ ನಾನು ಮಾಡಲ್ಲ, ನೀವು ಮಾಡಬೇಕು. ಓಕೆ, ಹಾ. Yes, what is the relative stiffness? Relative stiffness ಮಾಡ್ಬಿಟ್ಟು ಹೇಳಿ. Relative stiffness ಅಲ್ಲ, distribution factor. Distribution factor ಮಾಡ್ಬಿಟ್ಟು ಹೇಳಿ. What is the distribution factor? Yes, what is the distribution factor at A? And what is the distribution factor at D?
0.
0.
0, because fixed end. And intermediates are B and C. Find what is BA and what is BC, what is CB and what is CD. Here, what is the relative stiffness for all members? What is the relative stiffness for all the members?
4EI by L.
4EI by L. Because there is no end support, is simply supported. All are 4EI by L. But take care regarding what is the I factor. What is the flexural rigidity given? I, 2I, 3, 1.5I. You have to multiply. If I run the PPT, no use in this particular content, slope and MD, slope, deflection, as well as influence lines and all. We can do PPT for theoretical concepts, but it's a numerical one. We must work. Along with me, you have to sit and work. Then only you are getting the concepts. So joint B, C, members BA, BC, relative stiffness 4EI by L, 4 by 3I, BC 4EI by L, 8 by 4I. If you do summation, 1.33 plus 2, I think 3.334I. Once again, if you do this, fine. For this, CB, CD, 4EI by L, 4EI by L. So I am getting 2I. So here 4EI, 4 into 1.5, 6 by 3. Here also I am getting 2I. If I do the summation, I am getting
4EI.
4I. If I do K by sigma K, obviously 2 by 4 is 0.5.
0.5.
0.5. Here how much?
0.4 and 0.6.
0.4 and 0.6.
0.4, 0.6. See, ವಾಟ್ ಎವರ್ ದಿ ಮೆಥಡ್ ನೀವ್ ಹೆಂಗಾರು ಮಾಡ್ಬೋದು, ಈ ತರನಾರು ಮಾಡಿ ಗುಂಡ್ಗುಂಡಕ್ಕೆ ಏನೇನೋ ಬರ್ಕೊಂಡು ಡಿಸೈನ್ ಆಗಿ ಕಾರು ತರ ಚೆನ್ನಾಗಿರುತ್ತೆ, ವೀಲಲ್ಲಿ ಹೋಗೋ ತರ ಎಲ್ಲ. ಸೊ ವಾಟ್ ಎವರ್ ದಿ ಮೆಥಡ್, ಯು ಫೀಲ್ ವಿಚ್ ಒನ್ ಈಸ್ ಗುಡ್ ಫಾರ್ ಯು, ಗೋ ಅಹೆಡ್ ಅಷ್ಟೇ. ಸಿ ಇದ್ರಲ್ಲೆಲ್ಲ ಆಟ ಆಡ್ಬೇಕ್ರಿ, ತುಂಬಾ ಚೆನ್ನಾಗಿ ಖುಷಿಯಾಗಿ ಮಾಡ್ಬೇಕು, ಅಂದ್ರೆ ಬಂದೇ ಬರುತ್ತೆ. ಆಬ್ವಿಯಸ್ ಕ್ವಶನ್ಸ್ ಇದೆಲ್ಲ, ಸಿಂಪಲ್ ಕಾನ್ಸೆಪ್ಟ್. 3i/L 4ai/L ಅದನ್ನ ತೆಗೆದಿಟ್ಕೊಂಡ್ರೆ ಆಯ್ತು, ನಿಮ್ಗೆ ಏನೇನೋ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತೀರಾ. ಸೊ ಅದೆಲ್ಲ ಕನ್ಫ್ಯೂಷನ್ ಅಂತ ಬರ್ಲೇಬಾರ್ದು. ಓಕೆ, ಸಪೋರ್ಟ್ ಕಂಡೀಷನ್ ಮತ್ತಿದು ಅಷ್ಟಿದ್ರೆ ಸಾಕು. ಓಕೆ, ಶುಡ್ ಐ ಮೂವ್ ಆನ್ ಟು ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್? ನೆಕ್ಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಅಂದ್ರೆ ಇನ್ನೇನಿಲ್ಲ, ಒಂದು ಬೀಮ್ ಹಾಕೊಳ್ತೀನಿ, ಅದರಲ್ಲಿ ಬ್ಯಾಲೆನ್ಸ್ ಹೆಂಗ್ ಮಾಡೋದು, ಕ್ಯಾರಿ ಓವರ್ ಹೆಂಗ್ ಮಾಡೋದು ಹೇಳ್ಕೊಟ್ರೆ ಅಲ್ಲಿಗೆ ಈ ಮೆಥಡ್ ಫುಲ್ ಕಂಪ್ಲೀಟ್ ಆಗೋಯ್ತು. ಕ್ಲಿಯರ್? ಶಲ್ ವಿ ಮೂವ್ ಫಾರ್ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಥಿಂಗ್?
ಎಸ್ ಸರ್.
ಓಕೆ, ಎನಿ ಡೌಟ್ಸ್?
ಸರ್ ಇದು ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಫ್ಯಾಕ್ಟರ್ ಮೆಥಡ್ ಇದು ಫ್ರೇಮ್ಸ್ ಬರುತ್ತೆ.
ಫ್ರೇಮ್ಸ್. ಓಕೆ, ನಾವು ಫ್ರೇಮ್ಸ್ ಮಾಡೋಣ. ಫ್ರೇಮ್ಸ್ ಬಂದೇ ಬರುತ್ತೆ, ಫ್ರೇಮ್ಸೇ ಕೇಳ್ತೀವಿ. ಎಸ್, ಇವಾಗ ನೋಡಿ ಯಾವುದು ಎಂಡ್ ಸಪೋರ್ಟು, ಯಾವ್ಯಾವುದು ಇಂಟರ್ಮೀಡಿಯೇಟ್. ಫಸ್ಟ್ ಟೆಲ್ ಮಿ ವಾಟ್ ಆರ್ ಎಂಡ್ ಸ್ಪ್ಯಾನ್ಸ್? All are end spans. All are end spans only. In which one is simply supported?
C.
C, sir.
PC or CB is simply supported. For simply supported, what is the condition?
3i/L.
Remaining all?
4ai/L.
That's all. And also observe, joint A is, what is the distribution factor at joint A?
0.
Joint D?
0.
Joint C?
1.
1.
For joint B, how many members?
3.
BC, BA, BD.
BD.
Do this.
Okay, sir.
BA 4ei/L, so EI. BC 3ei/L, so again EI. For BD 4ei 8/5. (1.6). To do the summation,
3.6.
3.6.
How BC is 3i/L?
See, it is a end span. How it is simply supported, right? If the end support, and you see it is also like a simple support.
Okay.
CB, it's just like this. It is a simple support, right? It end support. If instead of this, if I put like this, it's not in a simple support. It's a proper cantilever.
Okay.
Okay. Now,
Sir, the BD member 8/5 is 2.66.
2.66. Okay. 8/5. How much? 2.6. How?
1 second. 8/5. Oh no, sir. 1.6.
1.6 only. Now 1/3.6. How much?
0.28.
0.28. 0.28. 0.48. Are you getting? 0.14. Okay. 0.28 is 0.52. 0.28. 0.28 is 0.62. So you are getting 0.3.
44, sir. 44. 44.
44. Okay. So the sum should be 1. If you do the sum, you are getting 1.
ಸರ್ ಸಿ ನಲ್ಲಿ ಓವರ್ ಹ್ಯಾಂಗ್ ಇದ್ರು 4EI by ಅಲ್ಲ ಸರ್?
ಎಲ್ಲಪ್ಪ
ಸಿ ನಲ್ಲಿ ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಇಲ್ಲ ಬಿಟ್ಟು ಓವರ್ ಹ್ಯಾಂಗ್ ಇದ್ರೆ
ಇಲ್ಲೇನಾರು ಸಿಂಪ್ಲಿ ಸಪೋರ್ಟೆಡ್ ಇಲ್ದಲೆ
ಖಾಲಿ ಇದ್ರೆ
ಇಲ್ಲೇನಾರು ಹಿಂಗಿದ್ರೆ 4EI by L.
ಓಕೆ ಸರ್. ಅಂದ್ರೆ ಆ ಕಡೆ ಸ್ವೇ ಮಾಡೋದಕ್ಕೆ ಸಪೋರ್ಟೇ ಕೊಟ್ಟಿಲ್ಲ ಅಂದ್ರೆ
ಸ್ವೇ ಇದು ಬರಲ್ಲ. ಇದು ನಾಟ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಸ್ವೇ ಫ್ರೇಮ್.
ಓಕೆ ಸರ್.
ದಿಸ್ ಇಸ್ ನಾಟ್ ಸ್ವೇ ಫ್ರೇಮ್. ದಿಸ್ ಇಸ್ ಎ ಪೋರ್ಟಲ್ ಫ್ರೇಮ್, ರೆಗ್ಯುಲರ್ ಪೋರ್ಟಲ್ ಫ್ರೇಮ್.
ಓಕೆ ಸರ್. ಸ್ವೇ ಫ್ರೇಮ್ ಅಂದ್ರೆ ಸಿಲೆಬಸ್ ಇಲ್ಲ ಅಂತ.
ಸ್ವೇ ಫ್ರೇಮ್ ಬರುತ್ತೆ. ಸ್ವೇ ಫ್ರೇಮ್ ಕೊಡ್ಬೋದು. ಸ್ವೇ ಫ್ರೇಮ್ ಕೊಟ್ರು ನಿಮ್ಗೇನು ಸ್ವೇ ಫ್ರೇಮ್ ಅಂದ್ರೆ ಹೆಂಗ್ ಗೊತ್ತಾ, ಡಿಸ್ಟ್ರಿಬ್ಯೂಷನ್ ಫ್ಯಾಕ್ಟರ್ ಎಲ್ಲ ಸೇಮ್, ಬಟ್ ನಿಮ್ಗೆ ಆರ್ಬಿಟ್ರಿ ಸ್ವೇ ಫುಲ್ ಅನಾಲಿಸಿಸ್ ಇಲ್ಲ. ನಿಮ್ಗೆ ಸ್ವೇ ಕಾಂಟ್ರಿಬ್ಯೂಷನ್ ಅಂದ್ರೆ ಅವೆಲ್ಲ ಇಲ್ಲ. ಅದು ನಿಮ್ಗೆ ಶಿಯರ್ ನಿಂಗೆ ಹೇಳ್ಕೊಟ್ನಲ್ಲ ಪ್ರೀವಿಯಸ್ ಡೆಲ್ಟಾ ಮಾಡೋದು,
ಓಕೆ ಸರ್,
ಅಷ್ಟೇ ಸಾಕು ನಿಂಗೆ. ಇವಾಗ ನಾನು ಇದನ್ನು ಹಿಂಗ್ ಕೊಡ್ಬೋದು. ಇದೇ ಫ್ರೇಮ್ ನಾನು ಇಫ್ ಐ ಗಿವ್ ಲೈಕ್ ದಿಸ್, ನೀನ್ ರೆಗ್ಯುಲರ್ಲಿ ನೀನ್ ಏನ್ ಮಾಡ್ತೀಯ ನೀನ್ ರೆಗ್ಯುಲರ್ಲಿ ಇಲ್ಲಿ 0, ಎಲ್ಲಿ ಇಲ್ಲಿ 0 ಈ ಜಾಯಿಂಟ್ ಗೇನು BA + BC, ಈ ಜಾಯಿಂಟ್ ಗೇನು CB + CD ಮಾಡಿ ಇಡ್ತೀಯ ಅಷ್ಟೇ.
ಓಕೆ ಸರ್,
ಆಯ್ತಾ? ಬಟ್ ಡೆಲ್ಟಾ ಬರಲ್ಲ. ಡೆಲ್ಟಾ ನಿಮ್ಗೆ ಅದೆಲ್ಲ ಆರ್ಬಿಟ್ರಿ ಸ್ವೇಮ್ ಅಂತ ಮಾಡ್ಕೋಬೇಕು. ಅದ್ ನಿಮ್ಗೆ ಇಲ್ಲ ಅದು.
ಓಕೆ ಸರ್,
ಆಯ್ತಾ? ಅದ್ರಲ್ಲೆಲ್ಲ MCQ ಬರಲ್ಲ ನಿಮ್ಗೆ. ಅದನ್ನ ಬಂದ್ರೆ ನೀನು ಅಲ್ಲಿ ಶಿಯರ್ ಕಂಡೀಷನ್ ಸ್ಲೋಪ್ ಡಿಫ್ಲೆಕ್ಷನ್ ಅಲ್ಲಿ ಹೇಳ್ಕೊಟ್ಟಿದ್ನಲ್ಲ, MAB MBA HAHD, ಅದನ್ನ ಮಾಡಿದ್ರೆ ಆನ್ಸರ್ ಬಂದ್ಬಿಡುತ್ತೆ ನಿಮ್ಗೆ.
ಡನ್ ಸರ್,
ಗೊತ್ತಾಯ್ತಾ? ಓಕೆ, ಬೇಕಾದ್ರೆ ಇದು ಒಂದ್ ಮಾಡಿ ನಿಮ್ಗೆ. ಅಂದ್ರೆ ಜಸ್ಟ್ ಫಾರ್ ಕ್ಯೂರಿಯಾಸಿಟಿ ಐ ವಿಲ್ ಗಿವ್ ಒನ್ ರೆಕ್ಟಿಲಿನಿಯರ್ ಫ್ರೇಮ್. This one. Or I can give like this. I will give hinge. Three meter, 4 meter, simple. 4 meter, 4 meter. I, 2I, I. ನೀವು ಆ ಫಿಗರ್ ನೋಡ್ಬಿಟ್ಟು ಭಯ ಆಗ್ಬಿಡ್ಬೇಡಿ, ಏನೋ ಕೊಟ್ಬಿಟ್ಟಿದಾರಪ್ಪ ಇವರು ಅಂತ. ಅದೇನೇ ಕೊಡ್ಲಿ ಏನು ಇರಲ್ಲ. ಕಾನ್ಸೆಪ್ಟ್ ಗೊತ್ತಿದ್ರೆ ಆಯ್ತು
ಸರ್. ಜಸ್ಟ್ ಗೆಸ್ ಸರ್, ಎಲ್ಲ 0.33 ಸರ್.
ಎಲ್ಲ
ಇಲ್ಲ ಸರ್. ಓಕೆ, 2i ಇದೆ. ಐ ಇದ್ದಿದ್ರೆ ಎಲ್ಲ 0.33 ಆಗಿರೋದು.
ಇಲ್ಲ ಚೇಂಜ್ ಮಾಡಿದ್ದು.
ಹಾ ಸರ್.
Try.
BC 3i by L, so ಉಳಿದೆಲ್ಲ 4i by.
ಸೊ ಜಾಯಿಂಟ್ ಫಸ್ಟ್ ನೀವು ಜಾಯಿಂಟ್ಸ್ ಗಳು ನೋಡ್ಕೊಂಬಿಡಿ. ಜಾಯಿಂಟ್ A, ಜಾಯಿಂಟ್ E, ಜಾಯಿಂಟ್ C. ಜಾಯಿಂಟ್ C is 1A, E.
E 0.
A and E are 0. ರಿಮೈನಿಂಗ್ ಗೆ ಜಾಯಿಂಟ್ B ಇಲ್ಲಿ how many members?
3 sir.
3. ಅಂಡ್ ಆಲ್ಸೋ ಐ ಸಿ ಸಮ್ಟೈಮ್ ನಿಮ್ಗೆ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಬೇಕು ಅಂದ್ಬಿಟ್ಟು ಏನ್ ಮಾಡ್ಬಿಡ್ತೀವಿ ಗೊತ್ತಾ, ನಿಮ್ಮನ್ನ ತುಂಬಾ ಬೇಗ ಒಂಥರ ಪ್ಯಾನಿಕ್ ಮಾಡ್ಬೇಕು ನಿಮ್ಮನ್ನ ಅಂತ ಡಿಸೈಡ್ ಮಾಡಿದ್ರೆ ಹಿಂಗ ಹಾಕ್ಬಿಡ್ತೀವಿ. ಪ್ಯಾನಿಕ್ ಆಗೋಗ್ತೀರಾ, ಏನಿದು ಇಲ್ಲ ಹಿಂಗಿದೆಯಲ್ಲ ಅಂತ. ಹಿಂಗ ಹಾಕ್ಬಿಟ್ಟು ಇದೊಂದು 3 ಮೀಟರ್ ಐ. ಎಸ್, ನೌ ಟೆಲ್ ಮಿ ಇನ್ B how many joints, how many members at B?
4 members.
4 members. ಆಯ್ತಾ? ಬಟ್ ಬೇಡ, ಇವಾಗ ಅದ್ ಮಾಡಕ್ ಹೋಗ್ಬೇಡಿ, ತಪ್ಪಾಗತ್ತೆ. ಅಂದ್ರೆ ಬಟ್ ಕೇಳ್ಬೋದು ಅಂತ ಐಡಿಯಾ ಕೊಟ್ಟಿದ್ದು. ರೆಗ್ಯುಲರ್ ಮಾಡಿ ಮಾಮೂಲಿ. ಪ್ರೀವಿಯಸ್ ಕೊಟ್ಟಿದ್ದಲ್ಲ ಅಷ್ಟಕ್ಕೆ ಮಾತ್ರ ಮಾಡಿ ಸಾಕು. ಅಂದ್ರೆ ಎನಿ ಟೈಪ್ ಏನೇ ಕೊಟ್ರು ನೀವು ಅಲ್ಲೇ ಕಾಂಪಿಟೇಷನ್ ಮಾಡ್ಕೊಂಡು ಮಾಡ್ಬೋದು ಅಂತ. ಆಮೇಲೆ ಸಮ್ ಸ್ಪೆಷಲ್ ಕೇಸ್ ಅಂದ್ರೆ ಆಕ್ಸಿಯಲ್ ರೋಲರ್ ಎಲ್ಲ ಬರೋದು ನಾಳೆ MCQ ಮಾಡುವಾಗ ಅಲ್ಲೇ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೇಳ್ತೀನಿ. ನಿಮ್ಗೆ ಇಷ್ಟು ಗೊತ್ತಿರೋ ಸಾಕು. ಒಂದೇನೋ ಇನ್ನು ಸ್ಪೆಷಲ್ ಕೇಸ್ ಬರುತ್ತೆ, MCQ ನಲ್ಲಿ ಬರುತ್ತೆ, ಆ ಪ್ರಾಬ್ಲಮ್ ಹಾಕಿದೀನಿ, ಅದನ್ನ ಅಲ್ಲೇ ಹೇಳ್ತೀನಿ. ಇವಾಗ ಇದನ್ನ ಮಾತ್ರ ಮಾಡಿ ಸಾಕು. Yes, here for CB 3i by L, for remaining all 4ei by L. Then yes, tell me what is BC, what is BA, what is BD, and what is DB and what is DE.
ಸರ್ ಬಿ ನೋಡಿದ್ರೆ ಅಲ್ಲಿ 2i ಮತ್ತೆ ಐ ಅಂತಿದೆಯಲ್ಲ ಸರ್, 2i 0.5 ಐ ಮತ್ತೆ 2i ಇದೆಯಲ್ಲ ಸರ್. ಬಿ ಸಿ ಮತ್ತೆ ಬಿ ಎ ಮತ್ತೆ ಬಿ ಡಿ ಅಲ್ಲಿ 2i ಅಂತಿದೆ, ಅದೇ 0.5 ತಗೊಂಡ್ಬಿಡುತ್ತೆ. ಇನ್ ಮಿಕ್ಕಿದ್ 0.25 ಗೆಸ್ ಮಾಡ್ಬೋದಾ?
ಆಬ್ವಿಯಸ್ಲಿ ಅಲ್ಲ, ನೀನ್ ಹಂಗೆ ತಗೊಳುತ್ತೆ ಅಂತ ಅಂದ್ರೆ
ಯಾಕಂದ್ರೆ ಅಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಸೇಮ್ ಇದೆ ಸರ್.
ದ ಪ್ರಾಬ್ಲಮ್ ಇಸ್ ಏನಾಗುತ್ತೆ ಕೆಲವು ಟೈಮು 3i/l ಅಲ್ಲ,
ಎಲ್ ಚೇಂಜ್ ಇಲ್ಲ ಸರ್, 3,3,4,4 ಇದೆ ಅದಕ್ಕೆ.
ಎಸ್ ಮಾಡ್ಬೋದು ಬಟ್ ಮೈ ಸಜೆಷನ್ ಇಸ್ ಕ್ರಾಸ್ ವೆರಿಫಿಕೇಶನ್ ಇಸ್ ಬೆಸ್ಟ್. ಇಟ್ಸ್ ಎ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್.
ಓಕೆ ಸರ್.
ಅಂದ್ರೆ ನೀವು ತುಂಬಾ ವೆಲ್ವಸ್ ಇದ್ರೆ ಮಾಡ್ಬಿಡಿ. ಬಟ್ ದ ಥಿಂಗ್ ಇಸ್ ಟುಮಾರೋ ಕ್ಲಾಸ್ ಟೈಮಿಂಗ್ಸ್, ಸಮ್ವನ್ ನಿರಂಜನ್, ಟುಮಾರೋ ಐ ಥಿಂಕ್ 2 o'clock ಅಲ್ಲ ಕ್ಲಾಸ್ ಟೈಮ್ ಟೇಬಲ್? 2 o'clock seems. I will check and I will confirm. 2 o'clock. ಎಸ್ ಮಾಡ್ಬೋದಪ್ಪ, ನೀವು ತುಂಬಾ ಪರ್ಫೆಕ್ಟ್ ಆಗಿದ್ರೆ ಮಾಡ್ಬೋದು. ಬಟ್ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ ನಲ್ಲಿ ರಿಸ್ಕ್ ತಗೊಳ್ಳೋದು ಬೇಡ ಅಂತ ಹೇಳ್ತೀನಿ ನಾನು.
ಅಂದ್ರೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಮಾತ್ರ ಸರ್ ಹಿಡಿಯೋದಕ್ಕೆ.
ಮಾಡ್ಬೋದು ನಿಮ್ಗೆ ಟೈಮು ಉಳಿಯುತ್ತೆ, ಮಾಡ್ಬೋದು. ನಿಮ್ಗೆ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲ, ಇದೇ ತರನೇ ಕೊಡ್ತಾರೆ, ನೀವು ಗೆಸ್ ಮಾಡೋ ತರನೇ ಕೊಡ್ತಾರೆ. ಯಾಕೆಂದ್ರೆ ಬೇಗ ಆಗ್ಬೇಕಲ್ಲ, ಟೈಮ್ ನಿಮ್ಗೆ ಟೈಮ್ ಬೌಂಡ್ ಇರುತ್ತಲ್ವಾ, ಗೆಸ್ ಮಾಡೋ ತರನೇ ಕೊಡ್ತಾರೆ ನಿಮ್ಗೆ.
ಡಿಸ್ಟೆನ್ಸ್ ಸೇಮ್ ಇದ್ರೆ ಮಾತ್ರ ಸರ್, ಡಿನಾಮಿನೇಟರ್ ನ್ಯೂಮರೇಟರ್ ಈಕ್ವಲ್.
ಹೌದು ಮಾಡ್ಬೋದಪ್ಪ, ಯು ಆರ್ ರೈಟ್, ಮಾಡ್ಬೋದು. ಟುಮಾರೋ ಅಂಡ್ ಡೇ ಆಫ್ಟರ್ ಟುಮಾರೋ, ಸ್ಯಾಟರ್ಡೆ ಅಂಡ್ ಸಂಡೇ 2 to 4 ಅಪ್ಪ.
Yes, sir.
As per timetable 2 to 4. Okay. Yes, any answer ಕೊಟ್ರೆ ಎಂಡ್ ಮಾಡ್ಬೋದು, ವೈಂಡ್ ಅಪ್ ಮಾಡ್ಬೋದು. ಆನ್ಸರ್ಸ್ see, I hope ನಾನು already we finished up to 70% of the syllabus. Any doubts? ಅರ್ಥ ಆಗಿದ್ಯಾ? ಕ್ಲಾಸಸ್ ಅರ್ಥ ಆಗಿದ್ಯಾ? ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
Sir, now what all we are left with, sir?
We are left with only influence lines.
Okay, sir.
Influence lines for beams, frames, trusses, arches.
Okay, sir.
Only we are left behind with influence lines. We covered remaining all the topics. Any doubts? ಏನಾರು ಅಂದ್ರೆ I hope doubts ಬರ್ತದೆ, ಬಟ್ ಅರ್ಥ ಆಗಿದೆಯಾ? ಏನಾರು ಯೂಸ್ ಆಗಿದೆಯಾ ಕ್ಲಾಸಸ್? Are you getting the importance of the subject? At least something you learned.
Sir, arches and cables ಮಾಡಿಲ್ಲ ಅಲ್ಲ ಸರ್?
ಕೇಬಲ್ಸ್ ಇಲ್ಲ ನಿಮ್ಗೆ, ಆರ್ಚಸ್ ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಲೈನ್ ಇದೆ ನಿಮ್ಗೆ.
ಓಕೆ, ಅದರಲ್ಲೇ ಹೇಳ್ತೀರಾ ಸರ್?
ಇವಾಗ ಸಿಲೆಬಸ್ ಈಸ್ ನಾಟ್, ನೀವು ಓದೇ ಇಲ್ಲ ಅದನ್ನ. ನಿಮ್ಗೆ ಸಿಲೆಬಸ್ ಮಾಡ್ಲಿ, ನೀವು ಓದಿಲ್ಲ ಅದನ್ನ, ಅಂದ್ರೆ ನಿಮ್ಗೆ ಯುಜಿನಲ್ಲಿ ಇರ್ಲಿಲ್ಲ ಅದು. ನೀವು 3 ಇಂಚ್ಡ್ ಆರ್ಚಸ್ ಅಂದ್ರೆ ನೀವು ನಾರ್ಮಲ್ ಥ್ರಸ್ಟ್, ರೇಡಿಯಲ್ ಶಿಯರ್ ಅದೆಲ್ಲ ನೀವು ಮಾಡ್ಬೇಕಾಗಿರೋದು. ಅವನು ಏನ್ ಸಿಲೆಬಸ್ ಇಟ್ಟಿದ್ದಾನೆ ಗೊತ್ತಾ ಅಲ್ಲಿ ಆರ್ಚಸ್ ಅಲ್ಲಿ? 3 ಇಂಚ್ಡ್ ಆರ್ಚಸ್, ಲೈನ್ ಆಫ್ ರೆಸಿಸ್ಟೆಂಟ್ ಥ್ರೂ ಹಿಂಜ್ಡ್ ಆರ್ಚಸ್ ಅಂಡರ್ ಡೆಡ್ ಅಂಡ್ ಡೈವ್ ಲೋಡ್ಸ್, ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಲೈನ್ಸ್ ಫಾರ್ ಹಾರಿಜಾಂಟಲ್ ಥ್ರಸ್ಟ್, ಬೆಂಡಿಂಗ್ ಮೂವ್ಮೆಂಟ್, ರಿಯಾಕ್ಷನ್ಸ್. ನೀವು ಇನ್ಫ್ಲುಯೆನ್ಸ್ ಲೈನ್ ಓದೇ ಇಲ್ಲ ಆರ್ಚಸ್ಗೆ.
ಸರ್ ಇದು ಬ್ರಿಡ್ಜ್ ಮೇಲೆ ಇವಾಗ ಟ್ರಕ್ಸ್ ಮೂವ್ ಮಾಡೋದು ಆ ತರ ಸರ್ ಇದು?
ಎಸ್, ಟ್ರಸಸ್ ಅಂದ್ರೆ ಅದೇ ಬರೋದು. ಒಂದು ಗರ್ಡರ್ ಇರುತ್ತೆ, ಆ ಪಾಯಿಂಟ್ ಲೋಡ್ ಸೀಕ್ವೆನ್ಸ್, ರೈಲ್ ಆಫ್ ಲೋಡ್ಸ್ ಮೂವ್ ಮಾಡೋದು. ಎಸ್, ಅದೇನೆ.
ಓಕೆ ಸರ್.
ವೆರಿ ಈಸಿಯೆಸ್ಟ್ ಟಾಪಿಕ್. ಅದ್ರಲ್ಲೇನಿಲ್ಲ. SFD BMD ಬಂದ್ರೆ ಆಯ್ತು. ಈಗ 70% ಆಗೋಗಿದೆ. ಸೊ ಇಷ್ಟರಲ್ಲೇ ನಿಮ್ಗೆ ಅರೌಂಡ್ 20 ಕ್ವಶನ್ಸ್ ಬರ್ತದೆ. 20 to 25 ಕ್ವಶನ್ಸ್ ಇಷ್ಟರೊಳಗೆ ಬರುತ್ತೆ. ಇಫ್ ಯು ಸಿ ಲಾಸ್ಟ್ ಇಯರ್ PWD ಕ್ವಶನ್ ಪೇಪರ್, ನಿಮ್ಗೆ ಕರೆಕ್ಟ್ ನನ್ನ ಕ್ಲಾಸಿಗೆ ಬಂದಿದ್ರೆ ಈ ಪಟ ಹೊಡ್ಕೊಂಡು ಹೋಗ್ಬಿಡ್ತೀರಾ. ಅಂಡ್ ಆಲ್ಸೋ WRD ಪೇಪರ್, ವಾಟರ್ ರಿಸೋರ್ಸ್ ಡಿಪಾರ್ಟ್ಮೆಂಟ್. ಯಾಕೆಂದ್ರೆ ನೋಡ್ತಾ ಇದ್ದೆ ಬೆಳಗ್ಗೆ, ಏನಿಲ್ಲ ನಿಮ್ಗೆ ಕರೆಕ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಫುಲ್, ಒಂದು ಚೂರು ಮಿಸ್ಟೇಕ್ ಮಾಡ್ದಲ್ಲೇ ಬರೀತೀರಾ. ಗೊತ್ತಾಯ್ತಾ? ಎಸ್, ಆನ್ಸರ್ ಹೇಳಿ, ಮೈಂಡ್ ಅಪ್ ಮಾಡೋಣ ಕ್ಲಾಸು. ವಾಟ್ ಇಸ್ CB? What is BC?
0.25.
Yes, 0.25. BC is 0.25. Yes. What is BA? 0.25. What is BD? 0.5. Summation should be 1. What is DB?
0.66.
0.67. What is DE?
3.4.
0.33. Summation should be 1. That's all. Any doubts? Any doubts? Okay. So dear students, let me wind up the class tomorrow at 2 p.m. Don't miss the class. Tomorrow we will solve how to solve MCQ questions with I have made a presentation as usual what we solved in for previous concepts. So tomorrow we will solve both SD method as well as MD method. Okay. Thank you.
Okay,
hello.
Okay, sir. Thank you.
Hello.
Yes, sir.
Yeah, both the classes are, I think Saturday, Sunday is only 2 to 4. Nimige.
Yes, sir. Saturday, Sunday, both the classes are 2 to 4.
Yeah. Thank you so much.
Okay, sir. Thank you, sir.
Thank you. Good night. Bye.
Good night, sir. Good night. Bye, sir.